What's going on, guys? So another year has passed, and it's hard to believe that I've been doing this video for 6 years now. So for those of you that don't know what this is, it's a video I do every year where I basically talk about every technology in web development, from programming languages to frameworks to tools and concepts, basically everything that I can think of, and I lay it out in a linear order so that you can create a plan of what you want to do and what you want to learn. Now, this year, I was a little more long-winded because I wanted to talk more about things instead of just saying, well, these are the front-end frameworks, these are the back-end frameworks. There's so many videos like that. I wanted to just elaborate more on stuff. So it's longer than I had anticipated. It's almost 3 hours long. But you don't have to sit here and watch it from beginning to end. You can obviously, watch a little here and there. You can skip around. I'm going to have timestamps with every single section down in the description. So don't let it overwhelm you. Obviously, you're not going to learn everything in this guide. I don't think that's even possible. But I want you to use it so that you can kind of pick and choose what you want for what you actually want to do, whether that's a full stack developer, front end developer, or whatever. All right, so hope you guys enjoy. Let's go ahead and get into it. Now, I just want to go over a couple things about this video. So one, it's not a trends video. I do add in some current trends, but it's an all-around roadmap starting from the very beginning, even with things like text editors and browsers. So it's very beginner-friendly. I don't assume that you know anything at all. This video doesn't focus on a specific path or a specific set of technologies. We look at everything, and I just try and guide you into choosing your own path in terms of technologies. You may want to be, a front-end JavaScript developer that works with React and its ecosystem, or you might want to be a Python developer that creates APIs and microservices with Django or Flask. It's really up to you on what you choose. There's no one-size-fits-all. Now, as far as my own opinion goes, I try to keep this video very objective. However, a lot of people do ask me what I use and what I suggest, so you will occasionally see something underlined or in bold, and that just means that that's what I personally prefer. So don't put too much into that because I'm just one person. And feel free to skip around. I'm going to have timestamps for every section. I know some of you have watched this every year, so you might want to skip around to certain parts. It is a very long video, so you may want to just listen to it like you would a podcast while you're driving or something like that. And then a couple things I want to mention. In addition to this video, I created a content guide on my website, which has just a list of YouTube videos and courses that correspond to the technologies and the topics in this video in the same order. So you can use that as kind of a supplement to this video. And then I also have a premium 300+ page ebook that is essentially a written version of this guide that goes a little more into detail and covers a little more about each technology and has some other topics as well. And that's just $9.99. I'll put a link to in the description if you're interested in that. All right, so before we get into certain technologies, let's look at some of the reasons why you may want to learn to code. I think this is the first step in creating a plan. What you choose as far as technologies is going to vary depending on what your overall goal is. So the first one is career advancement, meaning you want to work for a company as a developer. It could be a tech-based company or anything really. Developers are needed in a variety of industries, including tech, finance, healthcare, etc. And this seems to be the most common goal among my viewers and just developers in general. Now, I'd say freelancing is the second most popular goal. With the rise of gig economies and remote work, many people are turning to freelancing as a way to earn money on their own terms. And as a freelancer, you can offer your programming services to clients around the world. You would probably start out on your own, but you could end up building your own agency, which is what I ended up doing. And I actually found some real success within it. And you could offer general web dev and design services, or you could niche down and specialize in a certain area. So another area of entrepreneurship is creating products such as a SaaS or software as a service. And this does take a ton of time and effort and money, and I do think it's the riskiest of the three, but I also think if you find success, it can really pay off even more than the other ones here. My advice would be to start with this as like a secondary goal, and then later on, if you see the potential, you could then, move to it, do it full time. I think educational content, which is what I do, also falls into this area because you're creating a product. So some people learn programming simply because they have a personal project that they want to build or they enjoy it as a hobby, and that's absolutely fine. Money doesn't always have to be your end goal. You may even just start programming as a hobby and then switch to one of the other areas later on. I also put future-proofing because technology is constantly advancing. I think now with AI and some of the new tools that are coming out, it just shows you that the future is technology, and programming skills are always going to be in high demand. And by learning programming, whether it's web development or some other area, you're investing in your future and you're positioning yourself for success. And you may have another job right now. You may not even plan to work as a developer anytime soon, but it's a great skill to have. Okay, so continuing on with goals, you should decide which type of web developer you want to be. The three types are front-end, back-end, and full stack, and we're going to be talking about technologies that all three of these use. And I'm going to do what I did a couple years ago and color code the topics and the technologies. So we'll have blue for front-end, red for back-end, and green for full stack. All right, just to kind of categorize all of the different technologies, all the different frameworks and languages and so on, and make it a little easier to understand. All right, so a front-end developer is someone that specializes in the user-facing aspect of web development. So the technologies that I put here are examples of what you may use as that type. And you definitely don't need to know every single thing I put in these columns. Also, I'm not going to really explain them right now. We're going to talk about them throughout the span of this video, but you'll need to know, of course, HTML and CSS, and you'll typically need to know how to create dynamic pages, learn a front-end framework, understand how to consume APIs, and so on. As far as backend goes, you're going to be focusing on the server side of web development, so working with databases, servers, APIs, and backend developers are responsible for most of the functionality of a website, making sure it works correctly and efficiently. They use languages like JavaScript, using Node.js, PHP, Ruby, Python, and just about any other language. And then databases like MySQL, Postgres, MongoDB. Backend developers have nothing to do with the user interface or what the user sees on a website. Then you have a full stack developer, which has a broad range of skills, including both front-end and back-end development. And they have a good understanding of dynamic interfaces as well as back-end logic, working with databases, creating APIs, using HTTP, etc. And this is a full stack guide, which includes both front-end and back-end technologies. We're going to start off with the front end and then move to back-end languages and so on. For the first half of this guide, it's going to be very, very JavaScript heavy. And the reason for that is because JavaScript is the language of the front end, of the client side. So when you get into server-side development, you can use almost any programming language because that stuff isn't running in the browser or on the client. All right, so as far as tools and technologies, we're going to start at the very beginning here. So what are the highest level basic tools for web development? So of course you need a computer. I mean, you can write code on a mobile device, but I wouldn't recommend it. I do get a lot of questions about the type of system that you need to start programming with. You actually don't need much, especially for web development where you're most likely not running any hardcore compilers or working with intense 3D graphics or anything like that. I'd say just something with at least 8 gigabytes of RAM, and pretty much anything built within the last 10 years can be used for basic web development. You do not need a $2,500 MacBook Pro. As far as operating systems, it's really up to you. You can use Windows, Mac OS, Linux, unless you're writing platform-specific code, like if you're creating iOS apps with Swift, then you're going to need a Mac. But other than that, with web development, pretty much everything is going to be cross-platform, so it's just a matter of preference. I use all three. I prefer Mac OS, so that's my main machine for coding, but I do write code on Windows. I use Linux. I don't really write code on it, but I use it to manage my servers, both local and remote servers. But again, it's completely up to you when it comes to operating system. So you're going to need something to write code with, and that would be a text editor or an IDE, which is an integrated development environment. With most web development projects, you don't really need a hefty IDE. I'd say Visual Studio Code is the most popular when it comes to web development, especially front-end development. It's a text editor, but it's very intuitive. It has a ton of functionality. It has great extensions and customization. That's what I use. That's what I would suggest. Some others are Sublime Text, which is another one that I used for a couple years. Technically, it's a paid editor, but there's basically a never-ending trial, although I would suggest paying for it if you're going to use it for any amount of time. Atom is another open source, powerful editor with a ton of extensions. And then you also have Vim, which seems to be pretty popular, especially with Linux users. It's definitely more complicated as it's more of a command line editor. However, it's very powerful, very customizable, and the people that use it seem to really love it. Another thing that I want to mention that is helpful is to learn how to navigate your code or navigate your editor. So shortcuts, learn how to skip lines, how to go right to the end or the beginning of a line, how to move lines up and down without having to reach for your mouse. Learn how to do it within your keyboard. And a lot of them are, I guess, global. A lot of the same shortcuts in VS Code will work for Sublime Text. So it is very helpful to learn that. It makes your development much more efficient and much faster. When it comes to browsers, Chrome seems to be the most widely used for developers, Firefox being the second. I'm seeing a lot of developers use Edge a lot lately because it is Chromium based. Safari, Opera, Brave. Brave is one that I haven't used yet. I'm not sure how developer friendly it is, but I believe it does run on Chromium. But just about every browser has what we call developer tools, where you can see your HTML, CSS, you can edit it locally. You have your JavaScript console for debugging. You can see local storage and cookies and any data that's saved in the browser, the network tab to show you requests and response. So you want to get familiar with those dev tools. Now, as far as the terminal goes, it's not something you're going to need to learn when you're first starting out. However, as you progress, you'll eventually need to type some commands into the terminal. Even as a front-end developer, you'll often use NPM, which is the JavaScript package manager. You'll also be using Git for version control, although there are GUI tools for that. But I would say that if you're using Mac or Linux, then the default terminal is just fine. It's usually either Bash or Z Shell. But for Windows, you have the CMD command line or PowerShell, which are both proprietary. So when I use Windows, I usually download a tool called Git Bash, which is a Unix-based terminal. You also have the ability to use the Windows subsystem for Linux, but that's probably not something that beginners are going to use. So if you're a beginner and you want something that is Unix-based, I would suggest Git Bash for Windows. And then Hyper is another cross-platform terminal that you can use. It has a bunch of plugins, and you can really customize your interface. Okay, so now that you know your overall goal as a developer and you have your basic tools ready, let's get into the first and arguably the most important two technologies in web development, and that's HTML and CSS. In fact, even if you plan on solely being a back-end developer, I'd still recommend learning the basics of HTML and CSS. These are the two building blocks of the web, at least of the visual web. So everything that you see in a website or an application UI in the browser, it's brought to you by HTML and CSS. There's other things that make it function, but these are the two building blocks, and usually the first two things that you learn when you get into web development. So as far as HTML, you're going to learn how to lay out an HTML5 page with common tags and attributes. This will include the doc type, head body tags, headings, paragraphs, image tags with source attributes, things like that, meta tags for SEO, and so on. It's also important that you learn and use HTML5 semantic tags like header, footer, section, aside, rather than just using divs with IDs. This will make your website much more accessible and easier to understand for search engines and screen readers, and it provides a more clear, meaningful information about the structure and content of your websites. When it comes to IDs and classes, you're going to know when to use which. So there's no set in stone rules when it comes to this, but IDs are meant for unique elements and typically to reference elements from your JavaScript, or reference elements from your HTML in your JavaScript, I should say. And then classes are for styling, and you can have multiple elements with the same class. So start with the fundamentals of CSS. This is going to include things like font styles, colors, margin and padding, positioning. You want to get familiar with the box model, which is the concept that every HTML element is considered a rectangular box that contains content. And this will include the border, the padding, the margin, and so on. And understanding the box model is essential for controlling layout and spacing of your elements. Another important concept to learn is CSS specificity. So specificity determines which style rules are applied to an element when there's multiple conflicting styles. And specificity is based on the selectors that are used to target the element. Each selector has a specific weight that determines its priority. So for example, if you have an ID selector, that has a higher weight than a class selector. And a class selector has a higher weight than just the element selector. So you want to understand that so that you don't have a bunch of instances of the important flag to kind of overwrite specificity. I have trouble saying that sometimes. Another thing you want to learn is two things that absolutely change the game for CSS, and that's Flexbox and CSS Grid. So these two are, they make CSS easy to create layouts with. And before that, we had to use floats, and I went quite a few years creating layouts with floats, and it was an absolute nightmare. So those of you that are newer to front-end web development, you really don't know how lucky you have it, because Flexbox and CSS Grid, they might be a little overwhelming at first, but they're really easy to work with once you get the general gist of it down. So those are two things you definitely want to learn pretty quick. All right, so once you can create layouts for desktops, you'll want to get into mobile layouts and responsiveness. Responsiveness is the ability of a website to adjust its layout and its content based on the size and the orientation of the device that it's being viewed on. Every year, more people are viewing websites on their devices, and it's crucial that your websites are optimized for mobile viewing. Okay, there's tools that can help you out with this, such as the dev tools built into the browser. So in Chrome, for instance, you can toggle the device toolbar and see the site not only on different sizes, but with specific devices. So if you want to see it on an iPhone 8 or on a Galaxy or some other device on tablets, you can do that through the dev tools. And CSS media queries are at the heart of responsive web design. They allow you to specify CSS styles that only take effect when the viewport is in a certain range. So for mobile devices, you could apply a media query for, let's say, 600 pixels or less. And media queries may sound overwhelming, but they're actually pretty easy to work with. So these are what I would say are the absolute needed concepts and features to learn with CSS. Once you get a grasp on this stuff, you can move on to things like animations and transitions and making your designs more dynamic. And then there's a bunch of new features in CSS, or coming to CSS, I should say. Things like logical properties, dark mode media queries, scroll snap, which allows you to specify the scrolling behavior of your web page. We also have some new pseudo classes like is, where, and has that allow you to be more concise and dynamic with your selecting. So, and we're going to have nesting. So there's a lot coming to CSS. It's moving much quicker than it used to. I mean, we went years and years with what seemed like nothing being added to CSS, but now it seems like it's starting to pick up again. All right, so every other year, I've put things like Sass and CSS frameworks before JavaScript. And after thinking about it this year, since CSS frameworks are pretty much optional and Sass is definitely optional, I think after learning HTML and CSS, you should jump right into JavaScript. And notice I have backend here as well. I have the red box, and I would say it's optional for the backend. But if you plan on going into PHP or Python, and let's say you're going to use like template engines with PHP, Blade templates or something like that, that's all well and fine. But if you want any dynamic, interactive aspects of your UI, then you're going to have to know some JavaScript. If you only plan on building APIs and dealing with JSON data and microservices, stuff like that, then you can probably skip JavaScript if you're going right into some other language. I think a lot of people jump into front-end frameworks like React too quickly. It's important to understand the fundamentals of JavaScript. So you want to start with the basics, functions, loops, conditionals, things like that. You want to understand the browser environment and the window object, all the different methods and APIs that are in the window object. Obviously, you're not going to learn all of that right now at this point, but just understand that that stuff is separate from the actual JavaScript engine, from the core language. And then you want to learn about the DOM, which is the document object model. This is the interface in the browser that represents the structure of a web page as basically like a tree of nodes or a tree of objects. And the DOM provides a way for you to manipulate the content and the style of a web page using JavaScript. Understanding the DOM is crucial as a front-end or full-stack developer. So you want to learn to add to, remove from, traverse the DOM, manipulate styling, learn how to listen for events and create dynamic elements, button clicks, form submissions, things like that. Okay, and in 2015, there was a major update to JavaScript called ES 2015 or ES6. This included things like arrow functions, classes, template literals, destructuring. I would say that all that stuff, all those things that were added are now crucial to know in modern JavaScript. So you definitely want to learn that stuff. And then array methods. So you should learn these high order array methods like for each, filter, map, reduce. This will help you be able to manipulate arrays and perform complex operations on their elements. And then at its core, JavaScript is synchronous, single-threaded language, which means that everything is executed line by line, one after another. However, we do have ways to work with and write asynchronous code in JavaScript, which is important, especially when you're working with web applications that rely on HTTP requests to load data and content. So you want to get familiar with things like callbacks, promises. If you're going to make HTTP requests to some kind of API or backend, then you need to learn the fetch API that allows you to make requests over HTTP without reloading the page. This will include learning JSON, which is the format that is used when sending data between client and server. Okay, so now we come to some optional tools that can extend the capabilities of CSS. So Sass stands for Syntactically Awesome Style Sheets, and it's what we call a CSS preprocessor. So we create these files with either a .sass or .scss extension, and we can write not only CSS, but added functionality such as nesting, variables, functions, mix-ins. Some of these features like variables are already in native CSS. However, Sass variables are much more elegant than CSS custom properties, at least in my opinion. CSS will also have nesting soon, so I think the need for Sass is less and will be less than what it used to be, but I think it's still worth learning because it's really easy to learn. You could pick it up in like a weekend. Now, the browser doesn't read Sass files, so the way that this works is you use something called a Sass compiler, which will take those files with that special syntax and compile it into regular CSS. And there's all types of compilers, from command line tools to GUI programs. There's also compilers that can integrate right into your tooling if you're using something like Webpack, and we'll talk more about that later. So there's also something called Post CSS, which can do a lot of the same stuff that Sass can do and more. It's just implemented in a different way. It's implemented via JavaScript plugins. So if you wanted to like minify your CSS or automatically add prefixes or something like that, you can install those plugins. So Post CSS does have a learning curve, and it's usually used in your tooling and environment with something like Webpack. So I think at this point it would be more beneficial to learn Sass, just because it's really simple to get up and running. And again, you could just learn it in a weekend. I would say it's optional, but it can help you out. So CSS frameworks are another useful tool for front-end and full-stack developers. And again, just like I said with JavaScript, you want to make sure you learn enough CSS before you jump into a framework. So these can save you a lot of time because they come with pre-existing classes and components that you can use to speed up your development. They're also great for people that aren't really good with design themselves and creating UIs. And they're good for prototyping if you just need a quick layout. So with frameworks like Bootstrap, if you want to really customize things like colors, fonts, rounded corners, and stuff like that, then you're going to need to learn Sass, because you basically need to change those values and then recompile the Bootstrap CSS to include your customizations. As far as what is available, I put the most popular frameworks here, which are Tailwind, Bootstrap, I would say Materialize, and Bulma, but the two top ones right now are Tailwind and Bootstrap. So I would definitely suggest learning one of those two if you're going to jump into a CSS framework. Now, the big difference between Tailwind and Bootstrap is that Tailwind is very low level. It's a utility framework, meaning that you have classes to do certain things like set sizes, margins, padding, borders, etc. So you end up with a ton of classes in your HTML, which seems like a lot of people hate at first. However, you can really customize your layouts because you're not stuck with the same old alert and card classes, such as what you get with a framework like Bootstrap. Now, there's pros and cons to both. With Bootstrap, you don't have to write as much CSS, but it's more component-based than utility-based. So if you need an alert or you just want like a card class or something like that, you have those predefined styles. Now, Bootstrap also has some great JavaScript components like modals and accordion menus that can save you a lot of time because you don't have to create them from scratch. And if you don't know a lot of JavaScript, then it's great because you can just implement them really easily. So for me, I prefer Tailwind for projects that need a really customized UI, but Bootstrap for something where I need to create a layout fast, especially if I want to use modals and stuff. Now, some other options are Materialize, which uses Google's Material Design Style Guide. I really love the look of Materialize. It does also have JavaScript components. It's just not as popular as the other two. Bulma is a super lightweight, fast modular framework that has a pretty easy learning curve, so that's something else you might want to look into. The nice thing about these frameworks is that once you learn one, it's pretty easy to learn others. A big part of it is just using certain class names, which you can always look up, so it's not like you have to remember every single class name. Other than that, you just need to know how to set up and customize your layouts when using these. All right, so let's just quickly talk about design, because it depends on what you're doing as if you need to be good with design or not, or understand UI design. If you're a front-end developer at a company like Amazon or Microsoft or something like that, then you're probably going to have other departments that do everything that has to do with creating UIs and UX. And then it's your job to basically take that design and make it function, turn it into a user interface that works in the browser. However, if you're going to be a freelancer, then you pretty much need to know how to build a website soup to nuts. So you need to understand how to create layouts, and there's some basic principles that you need to know. Now, I'm of the opinion that even if you do plan on being a front-end developer at a large company and you're not really going to deal with with the design stuff, you should still know some basic principles. I've been asked to review a lot of websites, and sometimes it baffles me when people have they'll have their elements all squished together, and they don't realize that just that little bit of margin, that little bit of spacing or white space would make their site look so much better. Or they'll have a big hero image and the text is unreadable, and all they have to do is put an overlay and it would make it look so much better. So there's just a couple things that I think every front-end developer should understand. So we have scale, which is the sizing of elements relative to other elements around it. White space, which pertains to the spacing around elements. Again, you don't want to have your elements all smushed together. You want to have the right amount of margin in between each element. Color and contrast is a big one. You want to make sure all your text is readable. If you do have like a hero image and you have text over it, make sure your overlay is dark enough so that you can actually read the text. All right, visual hierarchy, so arranging your elements in order of importance. We have typography, which is text typefaces and font styles, things like that. And then alignment and flow, so direct the user's eyes to where they need to be. I think if you understand these basic design principles, it'll help you as a front-end developer. And Gary Simon's channel design course is actually really good for this type of stuff. So as far as creating design mockups and using design software, again, it depends on what you're doing, but I think you should at least know the basics of one of these programs. Just how to create a very basic layout, how to slice up images, things like that. And you have a bunch of options. I personally like Adobe XD. I used Photoshop for years when I was freelancing, and not just Photoshop, but also Illustrator. And I've just always went towards Adobe products, so I'm comfortable with XD. However, Figma is really popular right now, and that's probably what I would recommend for most people. It's free, it's browser-based, so it's cross-platform. It's great for collaboration. There's a lot of good things about Figma. That's probably what I'd recommend. Sketch is also great, but I do believe that it's Mac only, at least for creating and editing documents. And then InVision is one that I've seen a lot of lately. I've been working with a lot of designers for things like ebook covers and things for the website, and a lot of them are using InVision, and the documents that they send me are really, really cool. So that's something to look into. And then you also have wireframing solutions as well. If you don't want to create a whole mock-up, but you just want like a quick layout, an outline of a website. InVision's also good for that, but there's also mockups, MOQ, UPS, Lucid Charts, which I actually use for diagrams and charts, Balsamic, Wireframe CC. So there's a ton of different tools out there. I actually have a GitHub repo with I don't even know how many resources are on it, but it's called Design Resources for Developers, and it has just any kind of design tool that you can think of that's free is in that repo. It almost has 50,000 stars, so I'll put that link in the description if you're interested in that as well. All right, so we've talked about some of the main technologies of the front end: HTML, CSS, JavaScript. There's other essential tools that you'll learn along the way that are not going to take you as long to learn, but they're still essential. So we'll start with Git and GitHub. So version control is very important. That's something that you're absolutely going to need to know as a developer. It allows you to track your changes, manage multiple versions of your code, save your progress, collaborate with others, and much more. And there's a few options other than Git for version control, such as Subversion, but I rarely see anyone using that anymore. So Git is by far the most common solution, and it can get overwhelming when you get into the less common commands. But to start out, just learn the basics, add, commit, push, clone. And I know that there's GUI tools for Git as well. So there's desktop tools, there's VS Code has Git integrated with it. You can use that as well, but I would still suggest learning the basic commands in the command line. I have a crash course on Git and GitHub. It's a little bit older, but it's all extremely relevant. It's all the same commands and so on. So the browser dev tools, we talked about those a little bit. Those are extremely important for front-end and full-stack developers. All modern browsers have them. For instance, in Chrome, you can hit F12 on Windows or Command-Option-I on a Mac, and you'll open up the tools. It's a tabbed interface that splits up into different tasks. So you have the Elements tab, which is to view and edit the HTML and CSS. Obviously, if you edit it, it's just locally on your machine. You have your JavaScript console, which is important for errors and debugging. The Network tab will show every request that is sent to the server and the response that is sent back. And this is unbelievably useful to see what's going on between the client and server. And you can use the Application tab to see anything that's in your client-side storage, such as cookies, local and session storage. So you definitely want to learn at least those tabs early on. Next, we have NPM, or the Node Package Manager, and you won't need this at the very beginning of learning JavaScript, but it's good to get your feet wet and start experimenting with it. So NPM is a package manager. We can install different packages, whether it's a library, a framework, or just some kind of tool to use in your project. I believe there's something like 1.4 million open source packages in the NPM registry. So to use NPM, you do have to install Node.js on your system, which is really simple. If you're a front-end developer, you may never use Node.js itself as a runtime, but you will use NPM. And that includes installing most of the front-end frameworks. You use NPM. So Markdown is a lightweight markup language for creating and formatting text. It's something that you should probably learn along with Git, because the main README files are Markdown. So these are files that have a .md extension, and you can literally learn Markdown in a day. The syntax is very simple, and you can just go to markdownguide.org, and it has basically a cheat sheet for the syntax. So modern text editors and IDEs have a system for plugins or extensions, which do just that. They extend the functionality of the editor. And most developers have a suite of extensions that they use in their environment. So I use VS Code, and there's some common extensions and features that I use. So Emmet is an incredible tool for HTML and CSS, where you can use short snippets to write much faster. For instance, if you want to have a div with a class, you can just say dot and then the class name and then hit enter or tab. Now, VS Code by default includes Emmet, so you don't have to install it as a plugin or anything. But for some other editors like Atom, Sublime Text, I do believe you have to install it. Live Server is also a great extension for VS Code that I use. It basically just gives you a quick development environment, and it reloads the page automatically anytime you save. So it's really helpful for small projects. Prettier and ESLint are used for code formatting and linting. Bracket pair colorizer will give you color matched brackets, curly braces, parentheses. Other than that, I would suggest specific language and framework extensions. For example, if you're going to use PHP, you probably want to use something like the PHP in I think it's called IntelliFence. IntelliFence extension. If you use React, you'll want to use something like the React Redux Snippets extension. This will help you out immensely with code highlighting, IntelliSense, and all that. Now, whether you're making requests from the front end to a server, or you're creating a server, or both, you need to be familiar with HTTP clients, which are tools that can make HTTP requests. Your browser is one of those tools, obviously, and you have the Network tab to see exactly what's going on with the request and response. Now, you may need something more powerful like Postman. This is a desktop utility that lets you make any kind of HTTP request, including post, put, delete. Postman is essential for me when it comes to back-end and full-stack development, but it can be useful for front end as well. So if you need to test the response of a backend or a public API, you can use Postman. You could also use curl, which is a command line utility to make requests. And then to make requests from your code, obviously you have the fetch API, but you also have Axios, which is a library that you can use that I really love. I prefer it over the Fetch API. I think it's more full-featured and it's easier to work with, but it's similar to what Fetch does. All right, so there's going to be a couple slides where we talk about AI because it's such a huge topic in 2022 and now in 2023. We've made a lot of strides in this area. There's a ton of new tools coming out, some of which I'll mention later, but these two are really incredible and have really helped me immensely when it comes to productivity and learning. So first is GitHub Copilot, which is a VS Code extension. There's also extensions for other editors as well. Copilot uses artificial intelligence and machine learning to provide code suggestions and auto completion based on the context of what you're typing. So it uses a deep learning model that has been trained on a massive data set of open source code. And it's able to suggest entire lines of code based on just a few keywords. So you can use it as kind of an aid, but you can also use it to generate data, among other things. Now, GitHub Copilot can really improve developer productivity, and it can reduce the amount of time spent on, just routine coding tasks. It can also help new developers learn and code more quickly by providing suggestions and examples. I do think there is a downside to this, though, which I'll talk about in a minute. But the second tool is ChatGPT, which is an AI-powered chatbot that you can not only ask questions and get extremely useful answers and code samples, but you can also converse with it and it will remember the context of your conversation. So if you don't like the answer it gives, you can ask it to clarify or change the format of your question. So this technology is just taken the world by storm, and I think it's the first real display of what AI is capable of. And it's very useful to programmers because it can help you debug and solve problems, give you code examples, explain lines of code that you don't understand, and much more. Now, again, with all the good stuff that comes with these tools, I do think there are some negatives as well, especially for beginners. I think that it may start to dumb people down and make them lazier because they don't have to do as much work. And I'm not saying this about everyone or even the majority, but I do think it will cause some people to think less and become more dependent on these tools. I also think that we have the issue of a loss in jobs in the future, but I'm not going to really speculate on that too much. That's for a different video. With that said, if you do use these tools, just be aware of what you're actually learning versus what you're having the tool do for you. I think this is going to be a big issue in the future. So if you're a beginner, just don't let the tools do the work for you. Have them help you and have them help you understand. All right, so once you learn HTML, CSS, JavaScript, and you're able to use Git and GitHub, you want to learn to push your websites to a hosting account. You want to be able to host your projects on the web. And there's tons and tons of services. I'm going to mention some of the more intricate full stack hosting services later. These ones are more for front-end projects, and they're really, really easy to use. So first of all, you're going to need a domain name. You can do that before or after you push to a host, because when you use these services, they give you just a temporary kind of a dummy domain name just as a placeholder. And then you can register a domain name. I like to use Namecheap, but you can use plenty of other services. And then you point it to that web host. So Netlify is the first one here, which is probably my favorite for front-end projects, and it's very popular in the JavaScript community. They offer a really, really generous free tier, and there's features like form submissions and serverless functions, which I'll talk about in a bit. And it's super easy to deploy. Basically, you just push to GitHub, and then you log in to Netlify with GitHub, and you just simply select a repository. You select a certain branch from a repository, and it will just automatically deploy. And then every time you push to GitHub to that certain branch, it will automatically deploy on Netlify. So you get just continuous deployment, which is really nice. Now, Vercel is very, very similar. The way that you push your site to Vercel is very similar. They offer similar features. There's a generous free tier. So Vercel, they are the creator of the Next.js framework, so they're great for Next projects. I'll talk more about Next.js in a little bit, but that's another option. GitHub Pages is another free option for small projects. It's good for like personal portfolios, things like that, and super simple to set up because all you have to do is just name your repository in a certain way and it will just work. Now, the last one, cPanel. cPanel isn't a hosting provider. It's a platform where you can publish websites, you can set up and check emails, you can set up MySQL databases, and there's tons of hosting companies that offer cPanel, such as HostGator, Hostinger, InMotion Hosting, Bluehost. A lot of them have been around for years or even decades. And cPanel, I like it because it gives you everything in one place. If you want to set up all your emails and stuff, you can do all that from cPanel, where if you use these other services, you have to set up separate email hosting. You can also set up MySQL databases or Postgres databases. You can set up FTP accounts, although I wouldn't really recommend using FTP these days. And you can also push from GitHub just like you can with these other ones. So these are kind of the main easy choices that you have as a front-end developer. Okay, so let's say that you've learned everything we've talked about up to this point. If that's the case, I'd say that you're a foundational front-end developer. Now, in 2023, you're most likely going to have to learn a front-end framework and learn some more modern tooling in the front end. And I'm not saying it's impossible to get a job at this point. I've seen it happen over and over. And in a lot of cases, the company will actually train you to learn React or whatever the technologies that they use are. All right, so it's not impossible. If you're going the freelance route, I think that you could definitely start to work on getting clients. Just know your limitations, know what you can handle. There's a lot of small businesses out there that just need pretty simple websites, maybe some JavaScript functionality, but stuff that I think that you could handle at this point. Just don't go taking on like a custom e-commerce platform or something like that. So you should have just be able to set up a basic development environment with your text editor, your IDE, any plugins that you use. You should know how to navigate your code easily with shortcuts, run a local dev server with something like Live Server, use Emmet for fast HTML and CSS, things like that. You should also be able to create some decent looking websites with HTML and CSS. This includes semantic markup, layouts, CSS grid, and of course responsive design. Now, I'm not saying you have to be great with design. You should be able to look at a design and recreate it, but I do think you should understand some basic design principles, just very, very basic. I know that design is subjective in a lot of ways, but there are some things that are just objectively bad. When you have things squished together or you can't read the text, that's just bad, and you should be able to spot that easily. All right, so as far as JavaScript goes, you should be able to work with the document object model, interact with it. The amount of JavaScript you learn depends on what you want to do. I mean, if you ultimately want to be a PHP or Python developer, you can get by with just the basics. But if you're going to be a front-end developer and you want to be able to create dynamic UIs, then you should learn everything we talked about and continue your journey with JavaScript going into toolings, frameworks, and even Node.js on the back end. The fetch API is really important, and you should learn HTTP, so you should know status codes, just the main, 200, 404, 500, etc., and know how to make an HTTP request with fetch, know how to read the responses in the dev tools, things like that. You need to know how to initialize a Git repository, commit your changes. You should be able to create branches, clone other projects, make pull requests, and so on. I think that any dev job you get is going to be using Git. And if they don't use Git, they're going to use some kind of version control. So you should know how to deploy a project. I would suggest having a preferred domain name provider and a preferred hosting account, hosting service that you like that you can use rather than having 10 different ones that you use. Now, it's optional, but it's helpful to know a CSS framework like Tailwind or Bootstrap, and it can also be helpful to know Sass as well. So now that you have some foundational front-end skills, you need to choose your next path. So these are the main options that I came up with. And of course, they do blend into each other, but I tried to create a few separate categories based on what you'll be doing. I also put the colors for which type of developer would take that route. So the first one here, if your goal is more web design based, meaning maybe you want to try and freelance or create an agency that creates websites for other businesses, then you may want to dig further into creating really nice layouts. This means lots of CSS. You may also get into some no-code tools like WordPress, Webflow, Shopify, and these are great tools for freelancers. So that could be an option. You know, you're not really getting into building complex applications or super dynamic UIs, but more like brochure type websites. You can add some JavaScript functionality, make it dynamic, and so on. So that's one way that you could go. We also have the option to jump into the back end. If your goal is to learn PHP, Python, Ruby, Java, or any other server-side language, then you might want to move to this area next. If you're sticking with JavaScript, you may want to move to Node.js at this point, especially if you plan on being a back-end developer and your goal is not so much creating client-facing websites and applications, but more like APIs and microservices. In that case, there's really no need to learn React or web design or anything like that. So if you want to skip right to the server-side tech, you could do that now as well. Now, if your goal is to be either a front-end developer or a full-stack dev that can create dynamic interfaces, or you do want to go the web design route, but also want to be able to create more intricate interfaces, then I would suggest learning more about front-end tooling and moving to front-end frameworks. That's probably your best bet. And that's what we're going to talk about in the next slide, because I think that's the most common choice, the most common path to take from here. It's also what I would recommend to just about anyone that isn't doing strictly back-end. And then the last option I came up with is to keep working on your JavaScript skills and just your programming fundamentals in general, meaning that you don't move to a framework yet, but you maybe get into algorithms and data structures, learn more about design patterns, and so on. Websites like Code Wars are great when you really want to challenge yourself and you want to learn, just get better at problem solving, learning high order array methods and loops, and just becoming a better programmer and problem solver in general. So this option I think is good if you're coding as a hobby. It may not be the best option if you're trying to get a job or start freelancing quickly, because if you want to do that, you want to get into the practical technologies that are going to get you to work. Okay, so like I said, we're going to jump into front-end frameworks and tooling. Now, when I say tooling, I mean tools that help us have a more advanced front-end development workflow, as opposed to just having a single JS file included in our HTML where we have all of our JavaScript crammed into that one file. Now, when you use a framework like React, all this stuff is done under the hood, and if you want to jump right into a framework, that's fine. That seems to be what most people do, actually. However, if you want to look more into build tools, I think it'll give you a better overall picture as to what's actually happening and how things work under the hood, which I'm a big fan of. So to put it in simple terms, our projects can have a bunch of JavaScript modules, which are just files that we import and export our code from. And we can also use third-party modules using NPM. And then what these tools do is it takes everything, all of our modules, both custom and NPM modules, as well as other files and assets like CSS and Sass files, images, and so on, and it compiles it all into a single or maybe a few bundled files that we then include in our HTML, in our script tag. All right, so you have your development environment, and then you compile it down to assets that you have for production. All right, so let's take a look at some of these tools. Now, I may be a bit old school, but I personally still prefer Webpack. It's a module bundler that takes all your files and bundles them together. It's been around forever. It's essentially the initial module bundler. But it can be a bit difficult when it comes to configuration, when you're installing different plugins and loaders. Some of the other tools here are newer and they require less configuration. Webpack 4 or starting in Webpack 4, they call it zero config because you don't technically need configuration to use it, but once you want to install a plugin or a loader, then it can be a little bit difficult, especially for beginners. But it is very, very full-featured, and there's a ton of support and resources for it. So then you have Parcel, which is also a module bundler. It's a bit newer, it's less bloated, and it's more of a no-config solution. But it's also not as full-featured. So of course you have pros and cons. Then we have newer tools like Vite. So Vite is a build tool, but it isn't technically a module bundler itself. It leverages ES modules in the browser for development, so in turn, it runs faster. And when it comes to building your files for production, it uses a module bundler called Rollup. Now, Snowpack is another newer tool, which is kind of a no-bundle solution. It's very similar to Vite. It uses ES modules in the browser and also uses Rollup for building for production. I think tools like Vite and Snowpack are the future when it comes to front-end build tools. They're much faster, they're less bloated than things like Parcel or Webpack. However, Parcel and Webpack have been around longer and do have more support and resources available. Okay, so now we're going to look at front-end frameworks, and these frameworks use build tools like we just looked at under the hood, so you don't really have to deal with them or deal with any configuration. You have tools like Create React App that'll just scaffold up an application for you. So it's up to you if you want to really learn what's going on under the hood at this point, or if you want to do that later on. Now, all front-end frameworks have the concept of components. So everything in your website or UI is looked at as a component, from the navigation to the search boxes to the blog post cards. Everything is a component, and you kind of have to get into that frame of mind when you're using a front-end framework. State is another thing that you'll need to get comfortable with. State is basically just data. There's component level state, which is relative to a specific component in your UI. So for instance, if you have like a collapsible menu and let's say it opens and closes when you click something, that would have a piece of state to tell if it's open or closed. So to just most likely be a Boolean value. So that would be an example of component level state. Then you have global or app level state, which is data that's available to all components. So if you're fetching data from a database, like let's say blog posts or something, you'd probably want to have that data available to multiple components. So that would be your global state. And there's different tools you can use to manage your global state, both within the framework and also third-party tools. All right, now these frameworks were initially created to build what are called single page applications, or SPAs. And basically what that means is there's just a single HTML page that loads the bundled JavaScript from the framework. And then all the routes, everything, all the components, all the state is all in the JavaScript. Okay, so essentially your entire website or your entire user interface comes from the JavaScript, and it's just loaded with a single page. Now, in addition to that, in addition to SPAs, now we can use meta frameworks or full stack frameworks like Next.js, which is still React. Okay, Next.js uses React, but we can also write code that runs on the server as well as code that is run on the client side, run in the browser. And basically all of these frameworks have a meta framework that you can use with them. And I'm going to get into those meta frameworks later, but right now I just want to talk about the basic frameworks. All right, so first we have React, which was created in 2013 by Facebook, and I'd say it's the most popular front-end framework. It's absolutely everywhere. Technically, React it's actually a UI library, but it's used in the same way that frameworks are used. The only reason it's not a full-fledged framework is because some things, or a couple things, are missing, such as a router. You know, there's no router in the core React library. However, there is a package called React Router DOM that we can install and use. So things are just more broken up compared to a more full-fledged framework like Angular. Now, as far as learning curve, I would say React is in the middle. It's not the most difficult, but I also wouldn't call it easy. I would say React is my favorite framework, but I do have some issues with it. I think that in many cases, there's just too many ways to do the same thing, so it's not really clear which path to take. I think that's kind of my biggest beef with it. It does get updated quite a bit. However, the updates don't seem to have too much of an impact on code from older versions. One of the main reasons to choose React is because of its popularity. You know, you have access to a ton of resources and support, and there's a lot of React jobs available. But there's also a lot of React developers. Now, in addition to the framework itself, I just listed some things that are really popular in the React ecosystem or in these frameworks ecosystems. So Create React App is a CLI tool that you can use to quickly spin up a React application. If you wanted to install React and all its dependencies manually using NPM and then use some kind of module bundler like Webpack, you could absolutely do that. But Create React App does it really quickly and easily. And I do see it losing popularity because of Next.js. Next.js is a whole new way to use React, so a lot of people are using that over Create React App. Although I think for beginners, if you're just starting out, I wouldn't recommend jumping into Next.js. It's just too much at once. So Create React App is perfect for beginners to get started with the framework. Then we have the React router, of course. It's not included with the core library, so we usually install React Router DOM if you want multiple pages or multiple routes. And then JSX is the JavaScript syntax extension. That's what React components output. So it's essentially HTML from within JavaScript, which makes it dynamic so we can include variables and expressions and so on. Then we have the Context API, which can be used for managing global state. And then we also have third-party state management systems like Redux, which has been very popular for a long time. There's the Redux toolkit, which makes it easier to work with. And then we also have XState, which I see a lot of people using recently, and it's a state machine. I haven't used it myself, but I'm going to be getting into it soon. And then there's also a concept of hooks. So React components can be either classes or functions, and for a long time, classes were mostly used because you could do a lot more from class components. But in React 16, hooks were introduced, which allow your functional components to hook into the lifecycle, and you can manage state and stuff like that. So these days, you're probably going to be using functional components. All right, so next we have Vue.js, and Vue has been around, I believe, since 2014. And it's a component-based framework, so it has a lot of the same fundamentals that React has. I think it has a much easier learning curve than React. I'd say it's probably the easiest framework to learn. And one thing I like is that it wasn't created by some big conglomerate like React and Facebook or Angular and Google. It was created by a developer named Evan You, and it has a huge community around it. And just the fact that it wasn't created by a huge company and it's so popular really says a lot about it and how good it is. I say React is my favorite framework because it's the one I use the most, but if I were to start over and choose a main framework, then I can say that I'd probably choose Vue. But that's just my personal opinion. Don't let that affect, what you think or how you choose. As far as the ecosystem, Vue CLI is very similar to Create React App. It's used to spin up a boilerplate application. There's also Vue UI, which you can do this from the browser, from a GUI, rather than the command line. And then there's the Vue router, which is obviously used for routing. It deeply integrates with the framework. And then for third-party state management, we used Vuex for a long time, but now it's called Pinia. Which is essentially identical to Vuex 5. So it's a little weird. So you have Vuex/Pinia, I guess, for global state management. And then there's a couple different APIs for the components. The original options API, and then in Vue 3, they have the composition API, which I think is a little bit more difficult. I actually prefer the older options API. And then Vuetify is a UI library that's very popular. It uses Google's Material Design Guide. And I'm going to talk more about UI libraries or component libraries in a little bit. And then Nuxt.js is basically Next.js, but instead of React, it uses Vue. And again, I'll talk more about that later and more about static site generators such as Gridsum, which is comparable to Gatsby. All right, so those are just some of the things that you'll find in the Vue ecosystem. Okay, so next we have Angular, which has been around a really long time. I think it was one of the first big front-end frameworks, although it was much different back then. It was Angular JS, which is essentially a different framework than the Angular we know today. So I think Angular is the toughest to learn. Unlike React, it is a full-fledged framework and has a ton of features and a ton of things to learn, which makes it kind of difficult. Angular has its own router, its own HTTP client. It has services which help you manage state. Angular also uses TypeScript out of the box, so that's something else you have to learn along with everything else. I do find that beginners struggle a lot with the terminology Angular uses, like dependency injection and stuff like that. Don't get me wrong, I think Angular is a really powerful framework. I just think that it can be a lot for a beginner. And it's used mostly in like the enterprise world, big business, really large, complex applications where React and Vue can still be used in those environments, but they're also used a lot in startups as well as personal projects. And then as far as the ecosystem, we have Angular CLI, which is similar to, again, Create React App and Vue CLI. TypeScript, as I mentioned, Angular uses by default, so I'll talk more about TypeScript soon. NGRX is used to manage state. It's a third-party state management system that was actually inspired by Redux. And NGRX uses something called observables, which are very common in Angular. And observables are used to work with asynchronous data or data streams. And it's another aspect of Angular that I think makes it a little bit tougher to learn. And then for server-side rendering, we have Angular Universal, which can be comparable to Next.js and Nuxt.js. So if you want to render pages on the server, you can use that. And then you also have, of course, the dev tools for the browser, as well as VS Code extensions or whatever editor you use. Okay, so the next framework we're going to look at is Svelte, which is a newer front-end framework that's gained a lot of popularity in the last couple years. And one of the main selling points is its small size and fast performance. And with Svelte, it works a little bit different. So instead of creating a virtual DOM or a virtual representation of the user interface, like something like React does, it instead compiles the code into highly efficient and optimized vanilla JavaScript. So technically, it's a compiler and not a framework, but it's used in the same way as a framework, and it's a direct competitor to the others. And I think it has one of the easiest learning curves because it almost feels like just vanilla JavaScript, and it's also easy to integrate into other JavaScript libraries. Now, when it comes to the ecosystem, there aren't many things that aren't included if you use something called SvelteKit. So SvelteKit includes routing, state management, data fetching. It even has server-side rendering. So I'm a big fan of Svelte because it feels like what an experience of a user interface is supposed to feel like. And there's not all these different terms and limitations like you have with a lot of other frameworks. You define a global variable like you normally would, and there's no hooks or anything needed. It's just very simple, and that's what I love about it. Unfortunately, there's not a ton of jobs hiring for Svelte, so that's kind of the downside to it. But if you're building like a personal project or something, I think Svelte is a great option. Svelte with SvelteKit. And then you also have dev tools for the browser and for your text editors and so on. Now, we also have a new contender this year called SolidJS, and it's technically called a reactive library. It's very similar to React as it uses components that return JSX. However, Solid doesn't use a virtual DOM like React does. It uses a compiler more like Svelte. So another big selling point for Solid is how lightweight it is. I believe the entire framework weighs about 6.5 kilobytes and has extremely fast runtime performance. So SolidJS is reactive, meaning that it automatically updates the user interface in real time as the state of the application changes. And this makes it easy to build complex and interactive user interfaces without the need for a manual DOM manipulation or complex data binding. So as far as the ecosystem goes, if you go to the website, there's an ecosystem link which will give you a categorized list of all the packages that you can use with Solid. So there's testing packages and build tools. HoUI is a UI library for Solid that looks pretty promising. There is an SSR framework called Solid Start, which looks really cool. It actually looks a lot like Svelte Kit, but for SolidJS. But as far as I can tell, it's still in beta. So definitely something to keep your eye on. All right, so those are the main front-end frameworks that you have to choose from. I know that that's a lot of information to take in, but what I would suggest is just messing around with a couple of them and just seeing what feels the best to you, what feels the most natural, and then go off that. You know, you don't have to learn 3 different frameworks in and out. Just try each one. That's one of the reasons why I like to create a crash course every year or every 2 years on all the frameworks using or creating the same application so you can see the differences. All right, so next we have TypeScript, which is a superset of JavaScript, meaning that it is essentially JavaScript with some added features. And the main feature of TypeScript, hence the name, is static typing. So JavaScript, the JavaScript language, is dynamically typed, meaning that when we create a variable or we add a function parameter, we don't specify which type of data that variable should contain. So it's dynamic. It happens automatically. With many languages like Java, C#, C++, Rust, and many others, you actually have to define your types for your variables. Now, there are pros and cons to dynamic versus static typing. A dynamic language is good in terms of allowing you to write less code, which makes your write time faster. However, there are advantages to having to declare your types. For example, static typing can help catch errors early in the development process, which can then save time and improve the overall quality of the code. Static typing can also make the code more self-documenting and easier to read. And there are other features that TypeScript offers as well, especially when it comes to object-oriented programming. You have classes, interfaces, inheritance. A lot of this stuff is already included within JavaScript after the ES 2015 update. So the main reason you would use TypeScript is for static typing. And if you ask me, I would say learn JavaScript until you feel really comfortable with it, and then you can literally pick up TypeScript in like a weekend, at least the basics. It can get tricky when you start using it with front-end frameworks or even on the back end with Node.js, but it is a very valuable skill to learn, and it is big in the job market as well. Okay, so we discussed CSS frameworks earlier and how they help you create interfaces faster or websites faster as you have predefined classes to work with. Now, you can use CSS frameworks out of the box with a front-end framework like React. However, there are also what are called UI kits or component libraries. And these take it a step further and give you actual styled components. So they have their own state and their own properties, and they have the design, the CSS. So for instance, if you wanted a Bootstrap alert, instead of including a class, you would actually import the alert component into your code, and then you could use that, and that has its own props and its own state and so on. All right, so for React, you have a library called Style Components, which is very popular, and it allows you to do just that. You create components that are strictly for styling, things like cards and alerts and so on. Now, the thing with style components is it's up to you to actually style everything. It gives you the functionality to be able to create card components, but you actually add the CSS for that stuff. All right. In addition to that, you have other UI libraries that have the predefined styles. So for instance, Material UI is a popular UI kit for React, and it's based on Google's Material Design. So all the components have a certain look as far as the buttons, sliders, inputs, and all that stuff. Chakra UI is another one for React that's pretty simple and modular, and it doesn't use any specific framework like Bootstrap or anything like that. It's kind of its own thing, but I really like Chakra UI. And then for Bootstrap, you have a few different libraries. I like React Bootstrap. Basically, if you want to use, let's say, a Bootstrap navbar, you just import that, and you can use that. You can add whatever props and state are available with that component. So for Vue, you have Vuetify, which I already mentioned. That's, I would say, the most popular. It is based on Google's Material Design, like Material UI. If you want to use a Bootstrap component library, Bootstrap Vue is a good option for that. And then there's also Quasar, which is another popular kit built on Material Design. So lots of these are built on Google's Material Design style guide. For Angular, you have Angular Material, and then if you want to use Bootstrap, you have NG Bootstrap. There's some other ones as well. For Svelte, there is Svelte Material UI, which is similar to React's Material UI, and then you also have Svelte Strap. For SolidJS, I had mentioned there's a tool called Hope UI, which looks really cool. I've never used it, but from the look of the components, it has a really modern look to it. But there's so many of these. In fact, the Design Resources for Developers GitHub repo has a ton of these if you want to check that out. Okay, so learning testing is not something that every developer does early on. And who am I kidding? This is not something that every developer does ever. I think that learning how to write unit tests can be very beneficial. And if you're working for a company, it may be something that you absolutely need to do. If your goal is freelancing, my opinion is I think you should just skip testing because you're usually not creating these giant, enterprise level applications. And that's where I think tests really matter. So just to look at some of the examples of the different types of testing, unit testing is, I would say, the most common in web development. So basically you test for specific units of code, for example, a function, and the goal is to ensure that each piece of code is doing what it's supposed to do. All right. You also have integration testing, which is a type of testing that focuses on how different pieces of code work together. And then end-to-end testing is it tests the entire application from the user's perspective. You also have like performance testing, where it test your application under CPU load. This isn't really common in web development, though. A lot of frameworks and languages have testing capabilities included, but on the right here are just some popular libraries and frameworks for each language. So in JavaScript, I usually use Jest, but you have Mocha, Cypress, Jasmine. You have more specific tools like React Testing Library for React. And then all these other languages also have testing tools as well. I'm not going to go through every single one. Okay, so as a front-end developer, you should be familiar with the common web APIs or browser APIs. And I mentioned earlier, you should try to get familiar with the browser environment, and that includes these APIs. And there's more than this. These are just some of the common ones. So Canvas is useful for things like animation, dynamic graphics, and visualization. It's really common for HTML5 games. If you want to be able to do some really cool stuff visually, then you want to definitely learn the Canvas API. So geolocation will allow you to ask for a user's location. We've all had that pop-up asking for permission. This can be very useful for any kind of project that requires the user location. So you can get the latitude and longitude if you need to place it on some kind of map or get the local weather, whatever it may be. So the speech API is one that's really blowing up right now due to the AI chatbot stuff going on. So this API has speech recognition so that we can speak into a mic and then get the transcript, as well as speech synthesis to make the machine talk back with text-to-speech. So this is definitely something to get into, and honestly, it's really easy to learn and easy to use. So the audio and video APIs are used, obviously, to deal with media, whether you're creating a custom video player or music player or adding effects or anything like that. And then WebRTC is something I'm seeing a lot of lately as well. It allows you to have real-time communication over video and or audio. So you can create voice and video chat applications. Dennis Ivey actually has a video on this channel showing you how to do just that. Local storage, also extremely important. This allows you to store data on the client or in the browser. Of course, you don't want to put sensitive info in there. It's good for things like storing the user's name for a greeting or something like that. And like I said, there's a lot of other APIs as well, but again, just be familiar with the entire browser environment. All right, so the next category of technologies there's a few different names that these go by: full stack, meta framework, SSR framework. So these are designed to provide a complete solution for building web applications from front end to back end. And in my opinion, frameworks like these are really the future, because before we had either just client side frameworks like React or just server side frameworks like Express or Laravel. Now we have the best of both worlds. And of course, these do have their limitations. It's not like back-end APIs and microservices are going anywhere anytime soon. But there are a lot of benefits when using something like Next.js. So it's better for SEO because search engines can see the content rather than just the placeholder for the JavaScript bundle. It has performance gains because we don't have to wait for the JavaScript to render everything. It also provides simplicity for things like routes, where you can simply put a file named about.js into a certain folder, and then you have your route. So you don't have to have any kind of router or anything like that. So let's take a look at some examples. The most common, I would say, is Next.js. And if you're a React developer, this is probably what you're going to look to. I know it may sound confusing, like an inception of a framework within a framework, but just think of these as server rendering environments to run React or Vue or whatever inside of, and you get a bunch of cool extra features. So you get data fetching methods, file-based routing, image optimization. You can also create API routes right within the folder structure. So in some cases, you can use Next in place of, or Next API routes in place of an Express server for certain tasks. All right, now Next version 13 was released and introduced a new folder structure that allows for more modular and a more organized approach to structuring your application. Next 13 also takes advantage of React's new server components feature. Now, if you're a React developer, Next isn't the only option you have. Remix is another one that's really catching on, and Remix has some really cool features, such as the form component, which behaves like the browser's native form element, like a regular HTML form element with an action. It also handles transitions and loading states rather elegantly, and Remix automatically handles errors, interruptions, and race conditions. So you'd have to do some research to choose between Next.js and Remix. The one thing I can say for sure is that Next is more popular at this time, but it's also been around longer. Now, Nuxt.js is extremely similar to Next.js in terms of server-side rendering and what it does. It just uses Vue.js instead of React.js. So if you choose Vue as your main front-end framework, you're probably going to go with Nuxt for server-side rendering. And Nuxt supports hybrid rendering that lets you use route rules, which determine how the server should respond to a new request to a specific URL. It also has image optimization, file-based routing, and all that good stuff. Now for Angular, we have Angular Universal, which I mentioned briefly earlier, and it integrates well with the Angular CLI. It has rich debugging tools and has built-in support for lazy loading. I haven't personally used Angular Universal. Well, I shouldn't say that. I've experimented with it about a year ago, but I haven't really built any projects with it. All right, for Svelte, we have SvelteKit, which will render pages and components first on the server and then send it to the client as HTML. It'll then render the component or the page again in the browser to make it interactive. This is called hydrating the page. And you can control what you want rendered on the server as well as the client. You may want the user-facing site server rendered, but then have the admin area as a single-page application. It seems like SvelteKit is the go-to when using Svelte at this point. So next we have Blazor, which this may not be the perfect category for it, but I think it fits in here well because it is a full stack framework. However, it's not JavaScript, surprisingly. Blazor is a Microsoft UI framework that leverages C# and WebAssembly to create single-page applications that run in the browser. And of course, it has server-side functionality as well. So we haven't talked about WebAssembly. I will talk more about it later, but as a brief explanation, it's a low-level binary format for executing code in the browser, and that's how we're able to use C# to write client-side applications, as well, of course, as well as server-side code. So JavaScript is the language of the front end, but I think in coming years with WebAssembly, that may start to change. So if you want to get into C#, which I'll talk about when we get into server-side, Blazor is definitely something that you may want to get into. Some other features include hot reloading, lazy loading, and virtualization. Okay, so the next two are actually triple inception. So we have a framework within a framework within a framework because both Redwood and Blitz are built on top of Next.js. So that may be a turnoff at first glance, but these things offer a lot of different technologies all packaged up nicely for you to use, where usually you would use this stuff anyway. It would just be, it would be decoupled. So I actually like what Redwood and Blitz are doing. So like I said, they're both built on Next.js. Redwood includes Prisma, which is an ORM that supports all the popular databases. It includes TypeScript, GraphQL, Storybook, which helps you document and organize your components. Redwood is branded as a solution for startups, which makes sense because it includes all these powerful technologies in one place. So Blitz brands itself as a Next.js toolkit and picks up where Next leaves off. So it features a type-safe API layer. It has authentication and middleware. So there's scaffolding tools. It's a nice all-in-one solution. And I actually haven't built anything with either of these yet, but I'm actually excited to get into them this year and not only use them, but create some content and teach what I learn. All right, so the next batch of technologies we'll look at are static site generators, and these are tools that we use to create very performant and very optimized websites. And they aren't really used for large, complex applications, at least in my experience. That's not to say that you can't have dynamic data. You can use APIs, you can use headless content management systems, which we'll talk about next. And different data sources. What happens is all the data fetching happens before build time. So this makes your site really fast because it doesn't have to go out and fetch data while the user is using it, waiting for the data to be fetched. It's already pre-fetched. So one thing I want to say is that I think these are great for freelancers. A lot of the projects we get as freelancers are things like small business websites, and this gives you a real modern solution to quickly create very performant websites that are search engine friendly, which of course is very important to small businesses and important in freelancing. All right, so I'm going to start off with my favorite one, which is Astro. So it's one of those things where it just works how you would expect and how you would want. So you can build your site using JavaScript components, whether it's Astro components, which are extremely simple, or you can use React, Vue, Svelte. So you can use these other frameworks as well to build these fast performance static sites. Now, once you build your site and you have your components, it actually gets compiled into static HTML at build time. So it strips out all the client-side JavaScript that you use to create your components and so on. So it utilizes what they call the island architecture. So you can fetch data from anywhere, and one of the things I love about Astro is the top-level async, which means that you can use async await, or technically just await, because there's a top-level async, which means you don't have to put that await inside of a function labeled async. Now, Gatsby is a static site generator that uses the React framework. You can create pages that are simply React components, so you can still structure everything as you would in a regular React app, but with extra capabilities. So one unique thing about Gatsby is that it uses a GraphQL data layer that you can use to query data. And I know I haven't gone over GraphQL yet, but I will in a little bit. It's essentially a query language to query and mutate data. So if you have a blog or something like that, you can store the posts, whether it's in Markdown files or an API or a Headless CMS. Gatsby has all kinds of features that can help you fetch that data. And there's features like image optimization, code splitting, and more. Now, I know we talked about Next.js in terms of server-side rendering, but it also has static site generation capabilities as well. So there's an export command that you can use to export your project as a static site. Although there are some limitations and there are some guidelines and conventions that you have to follow in order for it to successfully build as a static site. And next we have Gridsome, which is very similar to Gatsby, except it's Vue.js instead of React.js. So you can see that a lot of these frameworks copy each other, which isn't really a bad thing because it gives you more options. And if you want to switch to something else, you already have an idea of how it works. So Gridsome is a big part of the Vue ecosystem. It has some great features for progressive web apps as well, which I'll talk about in a little bit. So there are other static site generators that aren't built or based on JavaScript. Jekyll is one of those options. So Jekyll is actually Ruby-based and uses the Liquid template engine. So although you don't have to be a Ruby developer to use it, it's actually the default generator for GitHub pages. So here's some other ones that I'll just go over really quickly. So Hugo is a generator that's based on the Go programming language. It was designed to be fast and flexible. It allows you to create websites quickly and easily using a variety of tools. Hexo is branded a blog generator, so it's fast and lightweight. It's a static site generator that's based on Node.js. And then Pelican is a Python-based static site generator that's designed to be simple and easy to use. So it's a good choice for small to medium-sized websites. So there's so many options when it comes to this stuff. You just have to kind of pick a couple, just read about them, try them out, and see what works for you. Okay, so I think this is a good time to mention headless content management systems because they often go well with static site generators. So when you create a website, especially a content-heavy website, you don't want to have to go in and edit your HTML files or your React components or whatever you're using. You could use something like Markdown, but if you're building websites for clients, you don't want to have them to have to go in and, go into their site structure and edit Markdown files. And you may not have the knowledge or time to create a custom backend to add blog posts or products or whatever it is that the application is using for resources. That's why WordPress got so popular, especially in the freelance world, because your clients want to be able to edit their own content. Well, with a headless content management system, it gives you that admin area to manage your content, except unlike traditional CMSs like WordPress, there's no user-facing website. Instead, it generates JSON data that you can then use with any front end, whether that be a single-page application with React, an Next.js website, a static site using Astro or Gatsby. You can literally use anything you want. It could even be for a mobile app or something. So first we have Strapi, which is built on Node.js and is completely open source. You can host it yourself because some content management systems are hosted elsewhere in the cloud on a different domain, and you basically just log in there, and then it gives you an API to use for your front end. But Strapi can be hosted anywhere, and you can consume the content API with either REST or GraphQL. You can upload photos and videos, and your API will include a URL so that you can embed them in your front end. It has Google Analytics integration. I'd say Strapi and Next.js is one of my favorite stacks to work with. So Sanity.io is a fully customizable headless CMS that allows you to define your own content models and schemas. It offers real-time collaboration features, a rich text editor, has a very flexible querying API, and there is a front-end option called Sanity Studio. So if you wanted to use that for your front end, you could. There's also SDKs, libraries, and tools that let you query your content and integrate it with websites, services, and other applications. So Keystone is something that I've actually used for a long time. I remember doing a Keystone JS tutorial years and years ago, and it was completely different. But it's really evolved into a powerful content management system, and it's modernized itself with GraphQL. The UI for admins is really nice and easy to work with. You can create primitive and advanced fields, create custom schemas, relationships, and much more. So Contentful is a cloud-based headless CMS that allows you to create, manage, and distribute content to any platform. It offers a flexible content model. It has a robust API, a wide range of integrations. It does have paid plans, but it does also offer a free plan that can be sufficient for personal projects. And there are literally just tons of these headless content management systems. This is just a small chunk of them. You have even Netlify has its own CMS, and you can also use WordPress as a headless CMS. You don't have to use the front-facing website. So the last few technologies that we've looked at, they fall into something called the Jamstack, which is a popular architectural approach to building websites that involve JavaScript, APIs, and markup, hence the acronym JAM. Originally, they put more emphasis on the JAM part. However, the term has evolved over time to really encompass a broader range of technologies and practices. So in short, I'd say the Jamstack emphasizes the use of static site generators, serverless functions, and other tools that really enable fast, secure, and scalable web development. And by following these principles of the Jamstack, developers can create websites that are easier to maintain, they perform better, and they provide a better user experience. Okay, so I wanted to put these two technologies in here, but I wasn't sure exactly where to put them. So Alpine JS is technically a front-end framework, but it works in a much different way. With the frameworks that I've mentioned, you build your app around the framework standards and you do things in a certain way, right? With Alpine, it's more like jQuery. In fact, I believe it even labels itself modern jQuery. And you basically just bring it into your existing project and you use custom HTML attributes to do things like data binding, listening for events, hiding and showing elements. So there's about 15 different attributes. They all start with X dash. So for instance, the X dash if attribute allows you to conditionally add or remove blocks of HTML. So it's kind of like if HTML was actually a programming language and had logic, this is what it would look like. And I think it's really cool. Alpine is often used with frameworks like Laravel. So oftentimes if you don't want to use something like React in your front end, you'll use like Blade templating, but then to add dynamic components to it, dynamic functionality, you use something like Alpine JS. So I think that's a really good solution. Now, the next one is Lit. Lit is a library that allows you to create your own custom components. It's actually built on the web component standard, and it provides reactive state, scope styles, and a declarative template system that's really, really tiny, fast, and expressive. And Lit components can be used across multiple apps and sites, even if those apps and sites are built on a variety of front-end stacks. So you could use Lit alongside other web technologies as well. All right, so these are tools that allow you to create advanced animation, visualization, transitions. I think that if you can create appealing visuals in your projects, it can really set you apart as a front-end and UI developer. And this stuff is definitely not needed. It is optional, but they're nice to add to your skill set. So first we have Motion UI, which was created by a company called Zerb. They also created the Foundation CSS framework. So Motion is a Sass library for creating transitions and animations, and you can add dynamic motion to various elements on your website, including things like buttons, navigation, menus, etc. And the library includes a wide range of pre-built animations and effects, as well as tools for creating your own. Framer Motion is a popular open source library for creating animations in React, and it provides a range of features for building fluid and dynamic user experiences. And it includes easy-to-use animation controls, gesture recognition, and support for 3D animations. 3JS is probably the most popular animation library. It has about 90K stars on GitHub. It's extremely powerful. It uses WebGL, which is a JavaScript API for rendering 2D and 3D graphics. So if you're looking to get into powerful graphics and 3D animations, 3JS is definitely something to check out. And then lastly, we have GSAP, which is the Green Sock animation platform. It's a robust tool set for creating very high performance timeline-based animations, and it uses tweens to give you more control over your animations. And even though it's a JavaScript library, you actually don't have to know a ton of JavaScript to start using it. All right, so before we jump into the backend section, I just want to quickly mention no-code tools, so like WordPress, Webflow, Wix. I think that these are really useful for freelancers and small agencies that create websites and small applications for other businesses and individuals. And you might see some programmers, particularly the young ones, trash these kinds of platforms, and some of them are scared that they're going to take their jobs. But honestly, in my experience, most business owners that aren't developers don't even want to deal with this stuff. They don't even want to deal with these no-code tools. They'd rather pay someone to build their website for them. And in my experience, these tools are used by developers or designers or freelancers, whatever you want to call them. So these are very popular platforms. I mean, WordPress still takes up a good chunk of the websites on the web. And you have like Webflow, Wix, Shopify is great for e-commerce. If you're to build an e-commerce shop from scratch, that's a lot of work. That's a lot of time, money, and work. And then tools like Kajabi, which I actually use for my video platform, are great, and for me to build that from scratch, I'd have to stop everything that I'm doing right now and work on that for the next year or so. And these are great to kind of save you that time. Okay, so we've talked about quite a few things. If you know even a fraction of what we talked about, then you're a front-end superstar. So you can call yourself a front-end engineer or whatever it is you want to be labeled as. I kind of think labels are stupid, but as a front-end engineer, you should be able to work well with a front-end framework. Which one you choose is completely up to you, but you should be able to create many types of projects using that framework and understand fundamental concepts like components and state and so on. You should be very comfortable with consuming data APIs, including fetching data as well as sending data to the server, and you should understand the important HTTP status codes and understand how a RESTful API works. Now, I'm moving full stack or SSR frameworks like Next.js to the need-to-know pile this year. They're just getting too big and becoming the standard when using front-end frameworks. So I know a lot of developers, they don't even use Create React App anymore. They just jump right into Next.js. And honestly, the only reason that I use something like Create React App is because I'm teaching, and I think it's good for beginners. And it's also good for really small projects as well. So some bonus skills that I'd say are pretty much optional but very beneficial and worth learning are TypeScript. So TypeScript is huge in front-end development, so knowing how to use it and work with types is definitely a plus. I think learning Jamstack technologies like static site generators and headless content management systems are also a great idea. I wouldn't say you need them to get a job, but they're very productive, especially for those of you that are freelancing and need to get projects out quickly. And then we have testing. And testing, it really depends on what you're trying to accomplish. If you want to write code at an enterprise level company, then testing is probably in your future. I wouldn't say it's a necessity, though. If you're a beginner, then I wouldn't even worry about testing right now, at least in my own opinion and experience. All right, so now we get to talk about other things besides JavaScript. So the reason that we've talked about so many JavaScript technologies up to this point is because we've just been talking about the front end for the most part. I mean, we have talked about like testing and stuff like that, but for the most part, it's all been front end, client side technologies. So when we move to the back end, to the server, you can use pretty much any language you want. So we'll start off with JavaScript though, Node.js. is a JavaScript runtime that was released in 2009. So in addition to running JavaScript in the browser, you can run it on your machine or on the server. And it's extremely popular in full stack development because a lot of people like to use the same language on both the front end and the back end. That's something that I really enjoy. And it's also very fast, it's scalable, it's great for APIs and microservices. There are some things that you wouldn't want to use Node.js for, and that's typically heavy computational tasks, video rendering, machine learning, stuff like that. These types of tasks are better suited for languages that are optimized for performance, like C++ or even Python. So it's good to know what you want to do before you choose a language. And I'll just mention that in addition to Node.js, there's another JavaScript runtime called Dino that was released, about 3 years ago, and supposedly it was going to just ruin Node.js, but I haven't really heard much about it. I do think there's some really cool features. I don't want to trash Dino. I just think it's funny how everybody reacted when it was released. So next we have Python, which is an amazing language overall. I don't think there's another language that has as many uses, or at least I should say high-level languages that have as many uses. From automation to web development to machine learning, data science, it's very diverse. Another reason for Python's popularity is its ease of use and readability. So Python code is generally easy to understand, easy to maintain, making it a great choice for both beginners and experienced developers. And in addition, Python has a vast library of pre-built modules and tools which make it easy to get started with a wide range of projects. So as far as web development goes, it has two really, really great frameworks, which I'll talk about in a few minutes. Next, we have PHP, which is great for what it does, which is practical web development. PHP seems to get a lot of flack, although it has gotten better over the years, especially with Laravel, which is easily in my top 5 frameworks. So PHP is not the most popular with large companies and enterprise, but it's still extremely popular with small businesses, web agencies, freelancing. The reason for that is because it allows you to create things really fast. Whether it's Laravel, WordPress, or even vanilla PHP for smaller projects, you can write procedural or object-oriented class-based programming. PHP was actually my first language, and I still love it. I don't write it much anymore, but I do plan on getting back into it. I plan on creating a Laravel course within the next year or so. I really like PHP. So next we have C#, which is a great general purpose language. Like Python, it can be used for many things. In my own experience with C# isn't really with web development, it's with Windows-based utilities. So C# is often used with a .NET framework, which is extremely powerful and provides a wide range of features for building robust and scalable applications. ASP.NET is used for, or ASP.NET MVC is used for web applications of all sizes. There is a market for C# developers for sure, and there's a lot of jobs out there. So it can be a great language to get into. So next we have Golang, which is a very powerful language created by Google. It's pretty popular in the enterprise world because of its performance and its scalability. It can be used for web applications, APIs, microservices. The syntax is pretty easy to read and write. One of the really cool things about Golang is that it has a really comprehensive standard library, which reduces the need for third-party packages and frameworks. So you can create a REST API pretty easily without using any other third-party frameworks. Much easier than if you were to use like Node.js without Express or anything else. There are frameworks available though, which I'll get to soon. So Ruby is a dynamic object-oriented language. It has a very concise syntax. In my opinion, it's similar to Python, but even more readable. It's almost like reading and writing English. And that was actually one of the goals for the creator of Ruby. A lot of people will say that Ruby is dead. I hate when people say stuff like that because if it's not cutting edge, then it's just dead, right? If it's not everywhere, then everyone says it's dead. Sure, there's more Python and Node.js jobs out there, but there's also more Python and Node.js developers. So you can still find some pretty good positions for Ruby programming, especially Ruby on Rails, which is its main web framework. And again, I'll talk more about backend frameworks next. So Java is it was actually the first language I was ever exposed to. It's an object-oriented language, so learning the principles of OOP, including abstraction, encapsulation, polymorphism, really important when dealing with Java. It's a very diverse general-purpose language, and you can use it for desktop applications, Android apps, web development. It's very popular in the big business enterprise world, and I don't really see too many startups or personal projects using Java, but again, that's just my own experience. Next, we have Kotlin, which is very similar to Java. In fact, you can use it for a lot of the same projects as it is interoperable with Java. So it seems to be the preference for Android apps at the moment. One of the key benefits of Kotlin is its concise syntax, which makes it easier to read and write than Java. And it is gaining popularity in the web development world as well. I wouldn't really suggest it unless you plan on getting into mobile, but that's just my opinion. So Rust has been blowing up for the past couple of years. It's known for its safety, its performance, concurrency. It's actually a systems language and is much lower level than the other ones that I've talked about so far, meaning it's closer to the computer's hardware like C and C++, although it's much easier to read and write than those two languages. So there's more abstraction than like C, C++. It has an ecosystem of libraries and frameworks. I think it's a good choice for high performance web applications, and it's also used with WebAssembly, which I think will be extremely popular in the future. So, and I'll talk more about WebAssembly later on. So Scala is another option for backend development. It combines functional and object-oriented programming paradigms. It powers the data engineering infrastructure of many companies and can also be used for creating APIs and microservices. So R or Erlang is not a language that I've ever used, and it seems to be mostly for things like statistical computing and data analytics, but it can be used for web development. It does have a few web frameworks. Then Swift is a popular general purpose language, mostly known for iOS development. So if you want to get into mobile apps, Swift is definitely going to be one of your main choices. There doesn't seem to be a lot of options when it comes to web development. So from what I've learned, I wouldn't suggest it unless you're getting into mobile. Okay, so now I want to get into some of the frameworks that these languages offer. So backend web frameworks are typically used to create APIs and microservices or to create full applications utilizing template languages and things like that. All right, so they usually have tools for creating routes or endpoints, interacting with databases, validating authentication, and so on. Some frameworks are more opinionated than others. I think that's important to understand. What I mean by that is some have a very specific way of doing things, and how you set your folder and file structure up, things like that, the conventions you use in your code are really strict. Those are opinionated and usually high-level frameworks with a lot of abstraction. Then you have unopinionated frameworks, which are usually more minimalistic, and they don't give you much out of the box. However, you have the freedom to structure things and do things however you want, and they're typically easier to integrate other third-party tools into. All right, now another thing that I should mention is MVC, which stands for Model View Controller. It's a common design pattern that these frameworks use. It basically separates the application's concerns into three components: the model, which represents the application's data and business logic, the view, which represents the user interface, and the controller, which manages the communication between the model and the view. Now, not all these frameworks use MVC in the same way, but a lot of them, they implement some form of it. So we'll start with Node.js. So Express is definitely the most popular framework for Node.js. It's literally everywhere in the Node world. And there's a lot of frameworks that are actually built on top of Express. So Express is very unopinionated, meaning you can do things the way that you want. There isn't much convention to follow. Express makes it easy to integrate other packages. So if you want to use like MongoDB as your database with the Mongoose library, you can do that easily. If you want to use Postgres with SQLize, that's easy as well. So there's no assumptions as to what to use in your stack. Express makes it easy to create routes, respond to HTTP requests, create middleware, and so on. And you can use MVC in Express, but I wouldn't call it an MVC framework. Now, Fastify has been gaining in popularity. It's a very high-performance web framework, and it's known for its speed and low overhead. It's often used for building APIs and microservices. It's very similar to Express in syntax, and it's also very minimalistic. Now, the next two frameworks for Node.js are feature-packed. You have Adonis and Nest.js, and with both of these, you get more out of the box. You're going to write less code, but they are more opinionated, and you have to follow certain conventions. Adonis actually reminds me a lot of Laravel's PHP framework. So if you've ever used Laravel, if you like that framework and you're looking for a back-end JavaScript framework, then Adonis might be for you. It's MVC based. You have database migrations, models, controllers, template engines, and more. Now, Nest.js, not Next, but Nest.js, is another full-featured backend framework, and it actually uses TypeScript out of the box, and in my opinion, it feels a lot like Angular. So it feels like Angular on the back end, just the way you set up controllers and so on, feels very similar. So I think that Angular with Nest.js on the back end can be a very powerful stack combo. And Nest is actually built on top of Express, but you can also configure it to use Fastify. So there's a lot of other Node.js frameworks, but these are the ones that I'd recommend. So I gave you two great minimalistic frameworks and then two higher level, more opinionated ones. All right, so Python has some great frameworks as well. So Django is another one of my favorite frameworks. It's very opinionated, it's full-featured. It allows you to build complex web applications with very little coding because there's so much out of the box. In fact, there's so much included that you can actually use Django without really knowing the Python language. You can just look at the docs and follow the standards and conventions. And there's database migrations, routing, there's even a complete admin area when it comes to your models. So let's say you're creating a blog and you create a posts resource or a post model, a category model. You can just put in a couple lines of code and those will show up in your admin area, and you can then manage your blog posts, your categories. You have complete CRUD functionality. So there's just a ton that comes out of the box with Django. I actually created a course on Django a few years ago where we build a real estate website. And I do have that course available, but it does need to be updated, and I will be updating it this year. So Flask is another awesome framework from Python, but I would say it's the complete opposite of Django because it's very minimalistic. In fact, I often compare Flask to Express, just the way that you create routes, the way that you use middleware is very similar. So if you want a framework where you have a lot of freedom and you don't, you want to bring other packages in and stuff like that, then Flask is a great Python framework. And then I wanted to put Fast API in here because it's really gaining in popularity. And like the name says, it's very fast and it's used to build APIs. So the performance is actually on par with Node.js and Golang. It also includes features that allow you to write code really fast. So it's robust and it's production ready. It's worth a look if you're into Python and you're looking to create web APIs. So next we're going to look at PHP, and Laravel is definitely the most popular framework when it comes to PHP, and it's really popular just in general. It was first released in 2011 and it's gained a large following due to its robust features, as well as its elegant syntax and ease of use. So a lot of people complain that PHP is a messy language, and I can agree that if you're using vanilla PHP, then it can get quite messy. You can get a lot of what's called spaghetti code, but Laravel is just so clean and elegant. Even people that bash PHP seem to think Laravel is a great framework. It offers a wide range of built-in tools and features. It has a really powerful ORM, which is an object relational mapping system. It has built-in authentication, support for database migrations, and Laravel also has a really large active community of developers. So definitely my pick when it comes to PHP, and definitely in my top 5 frameworks of out of everything. Symfony is another PHP framework, but in addition to being a framework, it also provides a wide range of reusable components. In fact, Laravel actually uses several Symfony components for things like HTTP and routing. So Symfony it's a very decoupled framework, which means every part of the framework can be used separately in other projects. So it's extremely powerful, but it does have a much higher learning curve, at least in my opinion. And I've seen quite a bit of Symfony in the enterprise world. So if you're a beginner, I don't think I would suggest using Symfony over something like Laravel, but that's just me. Everyone's different. So next we have my first MVC framework ever, actually my first framework ever that I learned, and that's CodeIgniter. So my first real complex application was created with this framework, and I used it throughout my freelancing career to build things like social networks, e-commerce websites, a content management system. So it kind of has a special place in my heart. Again, CodeIgniter 4 was in development for years. In fact, I thought the framework was completely dead. But in 2021, the stable version 4 was released, and I think it's a great framework, especially for beginners. I think it's a good introduction to MVC, where it doesn't do too much for you. You know, I think with Laravel, as great of a framework as it is, it does a lot for you, where CodeIgniter makes you do more of the work, but you also start to understand how MVC works a little better. If I don't know if I put that into the right words, but yeah, I mean it has a light footprint, good performance, and again, it's easy to use. It's not the most popular thing in the world, but I like it. So I also wanted to mention Slim PHP, which is very minimalistic and reminds me of Express, only for PHP. So if your goal is to create APIs and you don't need anything really full-featured and you want to structure your projects however you want, Slim PHP may be a good option. In fact, I think that it brands itself a micro framework. Now, if you're doing web development and using the Ruby language, there's a huge chance that you're going to be learning or using Ruby on Rails. And I said it before and I'll say it again, I think Rails is one of the best frameworks ever created. It's amazing for rapid development. You can spin up a CRUD application, connect to a database in literally minutes, and it has incredible scaffolding tools, migration tools. The code is Ruby, so it's very elegant and easy to understand. Ruby on Rails is big on the DRY principle, which is don't repeat yourself. It is very opinionated, probably one of the most opinionated frameworks, and it uses convention over configuration. So I think this framework can be great for freelancers. I did quite a few Rails projects when I was freelancing. As far as jobs go, they definitely have declined over the last 10 years, but they are still out there. And again, I said it earlier, there's not as many Ruby developers as there are Node.js or Python developers, so you do have a decent shot at the jobs that are available. Now, in addition to Ruby on Rails, you have the Sinatra framework, which is a good alternative to Rails because it's very minimalistic and Rails is very opinionated. So Sinatra actually calls itself a micro framework. So it's good for, smaller APIs, things like that. So Golang, it has a very extensive standard library. I think I mentioned that in the last slide. So you can do a lot without a framework, but there are still frameworks available. So Gin is probably the most popular Golang framework at this time. It's used to create modular and scalable web applications. It has a very similar syntax to Django, and it's a great framework for smaller personal projects as well. So next we have BGO, which allows for fast creation of back-end web apps as well as REST APIs. again, this is similar to Django, and it's a full-fledged MVC framework. And it integrates an ORM easily to query a database, and it comes with command line tools that work, again, similar to Django's. And then Echo is a high-performance minimalistic framework for Go, and it's popular for building microservers and RESTful APIs. And it has an optimized router, data binding, and rendering capabilities, as well as templating. So let's move into Java. So Spring is very popular in Java world. It's a programming model and ecosystem and has several parts to it, including the Spring MVC framework, which is used to create web applications. And it seems to be Java's version of C#'s ASP.NET MVC. And I find that there's a lot of similarities between Java and C#. So if you're a Java developer and you're getting into web development, chances are you're going to learn Spring. And this just like any other Java technology is used a lot in the enterprise world. And then Struts is another framework that Java uses. It was developed by Apache, and it's used for large applications and has a great community. And there's all kinds of plugins that you can use with Struts. It comes with some plugins for things like JSON and REST API development. And then Blade, both Spring and Struts are used for larger projects. So I want to mention Blade, which is suitable for smaller and personal projects with Java. And Blade focuses on simplicity and also has tools for security. Now, as far as Kotlin goes, Kotlin can also use Spring as of version 5.0, so it's a popular choice for Kotlin users. Javelin is a very lightweight framework for Kotlin and can be used for smaller applications. It's designed to be simple in blocking, but also can be configured to be asynchronous. And it supports OpenAPI. It runs on top of Jetty, which is one of the most stable web servers on the JVM, or the Java Virtual Machine. We also have Ktor, which is another lightweight framework by JetBrains that is reliable and stable. When it comes to C#, we have obviously the .NET framework. We have ASP.NET Core, which is a cross-platform general-purpose framework. Obviously, it uses .NET, and it's high performance, high scalability. It's great for large applications. And then you have ASP.NET MVC, which is built on top of ASP.NET, and it's specifically for web applications. And obviously, it implements the model view controller design pattern. So using C# with ASP.NET is a reliable and elegant solution for full stack web development, and there's plenty of jobs for it. And then finally for Rust, we have the Rockets framework, which allows you to create fast and secure web apps. And it's a type-safe framework. I looked at some of the syntax when it comes to writing routes and creating an API, and it seemed pretty clear and easy to understand. I've never used it personally, but I did take a quick look at it. All right, so now we're going to look at some database options. And no matter which language or framework that you use, you're going to be dealing with some kind of database if you're building full stack applications or back-end APIs. Now, there's different types of databases, and just like with anything else in web development, there's no clear best option. The two main types are relational databases and NoSQL databases. So I just want to quickly go over some points for each of these, as they're just like with anything, there's pros and cons, and there's different situations where one may be more beneficial than the other. So relational databases have been around since the 70s. They've been around a long time, and this can be a good thing because we know what they're capable of. There's lots of knowledge and support out there. They use a traditional table structure or table-based structure with columns and rows. So you can kind of think of like an Excel spreadsheet. Most relational databases use SQL, which is structured query language, which if you're going to be a back-end developer, you should definitely learn. I wouldn't say it's as hard as learning a regular programming language. There's not as much to it. So learning the basics can be done pretty quickly. Now, as the name implies, these are great for relationships or related data. So let's say a social network where you have users and posts friends, photos, and just a whole bunch of data that can be related to each other. So relational databases are also very strict and rigid when it comes to the structure. You basically need to create your tables and then all your fields, even the type of data that field is going to hold before you do anything within your application. So this can be a pain to deal with, but then again, it does promote consistency, security, and reliability. They're also really good with complex queries that involve multiple tables and so on. So NoSQL or NoSQL databases are a newer type of database, and there's actually many different types of NoSQL databases. You have document databases, column-based, key value stores, and there's a lot more, but I'll mostly be talking about document databases as they seem to be the most popular. So data gets stored in the form of a document, which is basically a JSON object. So they're stored in collections. So you have collections of documents, which again are essentially just JSON objects, key value pairs. One thing about NoSQL databases is they're very, very flexible and schemaless. So you don't have to go and define all your fields and all your types and stuff like that at the database level. You can do that through your application, through an ORM or an ODM, object data mapper, but you don't have to do it at the database level like you do with a relational database. All right, so they're also very, very scalable and used to store massive amounts of data. They're not so good with complex queries, though. So if you have complex queries and lots of related data, you may want to use a relational database. And if you have data that is fairly simple in terms of structure, but you have tons and tons of it, then you may want to choose NoSQL. But I will say that in most projects, especially small to intermediate projects, you could use either one. All right, so now we're going to get into the actual database management systems, or DBMSs. So we're going to start with the relational ones, and then we'll move to NoSQL, and then we'll also look at some other types as well, cloud databases, file-based, etc. So Postgres or PostgreSQL or PostgreSQL, however you want to pronounce it, is a relational database that has intuitive functionality and versatile security. So it's also known as an object-oriented database. This makes it easy to work with complex data models and relationships, and it provides a more intuitive way to interact with the database. So when I started web development, everyone was using MySQL or MySQL. However, in the past few years, Postgres has really came up in popularity. So it's really popular for startups, and it's used by companies like Apple, Skype, Etsy, and Cisco. So next we have MySQL or MySQL. It's another popular relational database system, especially in web development, and it was the first database that I personally had experience with. It's very popular in PHP world. So you have the LAMP stack, which stands for Linux, Apache, MySQL, and PHP, and that was huge when I was learning web development. And it's also used with large companies like Google, Udemy, Netflix, and Amazon. Now, Oracle is a popular commercial relational database system that's used in the enterprise level applications. So it's known for its reliability, scalability, and security, and it handles complex data sets really well. Now, you probably won't see Oracle used much in the smaller to medium-sized projects or startups. It's more of a big business solution. It's used by Amazon, American Express, Verizon, and many other big companies. Then we have Microsoft's implementation of SQL, which is MS SQL or MS SQL. Again, like Oracle, it's used in a lot of big business. It's a commercial solution, although there is a free tier with limitations, and it's used by companies such as Bank of America, UPS, JP Morgan Chase, and so on. So all four of these are similar when it comes to managing data via SQL, structured query language. There are variations of the language, but it's pretty easy to transition from one to another. All right, so now we're going to look at some NoSQL databases, or NoSQL. I know a lot of people give me crap for saying SQL, but MongoDB is probably the most popular one. It's a document database. And like I said, data is stored in documents which are formatted like JSON objects. In fact, MongoDB uses something called BSON, or BSON, which is a superset of JSON. And I think one big reason why Mongo is so popular in the JavaScript world or Node.js world is because it's structured literally like JSON, like JavaScript. So it's really easy to work with, and it's nice to have that type of structure in your full stack JavaScript application. MongoDB is very scalable, and of course, you can use MongoDB with other languages as well. It's not just with Node.js, with JavaScript. All right, and I'm going to talk more about MongoDB Atlas in a minute, which is a cloud database. Now, if you are going the NoSQL route, I'd probably say stick with MongoDB just because it's so much more common than these other examples, especially in web development and smaller to medium-sized projects. But some examples of other NoSQL databases are Cassandra, which is a column-based database. It is highly scalable and flexible, as are most NoSQL databases, and it's used by companies like Apple. It's actually used with iCloud hosting. Twitter uses it to store and manage data, and then eBay uses it, I believe, for analytics. Couchbase is another document database similar to MongoDB. It's designed to handle really large amounts of unstructured or semi-structured data. I believe LinkedIn uses Couchbase for its notification system. And we also have Amazon's DynamoDB, which is an implementation of Dynamo, and it's a fully managed document database and key value store, and it's built for scalability and performance. Some companies that use it, of course, Amazon, also Netflix and Airbnb. Now, I will say that most of these NoSQL databases, with maybe the exception of MongoDB, are really built for really, really large data sets. So if you're creating a personal blog, you're probably not going to use Couchbase. You're probably going to use something like Postgres, MySQL, or even MongoDB. So now I want to look at serverless or cloud databases. These are extremely popular in 2023 and beyond. These are databases that are obviously hosted in the cloud, so you don't have to install and manage them on your own server. And I think that this is the general direction that we're going in when it comes to data. They provide scalability, flexibility, and you don't have to worry about the infrastructure and the maintenance. So we'll start off with MongoDB Atlas, which is the cloud version of MongoDB, and it's actually what they suggest using over, a local implementation. And as with the rest of these options, there's a very generous free tier, and then it's pay as you go. Once you go into production, if it's, more than just a simple personal website or something like that, then you just pay as you go. And it's great because you can set up your development database while you're developing and then just switch to your production database when you deploy. And it's as easy as just swapping out the database string in your back end. You don't have to do any extra installations or any work on a server or anything like that. It's very secure. You can make it so that only your development IP and your production server IP can access it. You can access your data via the browser, but there is a much more intuitive desktop app called MongoDB Compass if you want to manage your data directly, right in the database, not through any application. So next we have Firebase, which is owned by Google and offers a real-time NoSQL database, as well as a lot more. It's actually an entire platform. So it offers things like authentication, file storage, serverless functions. So it's essentially an entire platform for building applications, and it's great for small to medium-sized projects. The one downside is that you are tied into Google's architecture for everything if you do use Firebase. Now, another option that you have, which is very similar to Firebase, is Supabase. And Supabase has really blown up in 2022 and 2023. So it's essentially a backend as a service. So again, you don't have to install or manage any databases. It does offer authentication. There are some differences with Firebase versus Supabase. Supabase is actually built on top of a Postgres database, while Firebase is built on top of a NoSQL database. Another important thing to mention is that Supabase is not a proprietary piece of software like Firebase. So since it's an open source project that uses an open source database, Postgres, then you're not locked into any one particular vendor like you are with Firebase and Google. Now, FaunaDB is another one that I've seen a lot of this past year. What's cool about Fauna is that they offer both NoSQL and relational data models, and they also provide advanced features such as support for ACID transactions. They have native support for GraphQL as well. And then AWS also offers a lot of options. There's RDS, which is Amazon's relational data service, where you can have a Postgres database in the cloud. That's something I've used a few times as well. Now, I want to talk a little bit about file-based databases, which are used for very small projects. So if you have like a personal website with a directory of staff members, or you have a simple blog or something like that, sometimes using Postgres or MongoDB can be overkill. So one of these options is much less overhead and less work for you. So SQLite is very common. It's actually used as the default in many backend frameworks such as Laravel and Django. It doesn't take any work to set up. You simply have to create a file called database.db or whatever. There's also desktop apps and editor plugins that you can use to go in and view and manage your data in an SQLite database. Now, I put Markdown here, or Markdown files, which is definitely not a database. However, Markdown files are a good replacement for a database for really small projects, such as personal blogs. So I created a blog not too long ago for a friend, and I used Gatsby, which is a static site generator, along with Markdown files, and they love it. And, you do have to go in and edit Markdown and create new files, but once you know how to do that, it's simple. We also used them in my Next.js course for the DevSpace blog project. So another option is H2. H2 is a lightweight open source database that uses a file-based format. It supports SQL and provides a web-based console for managing data. Now, I put Redis here, although its primary use is more for caching. It's more of an in-memory database. However, it does have the ability to persist data beyond memory and write it to disk. So Redis may be something you want to look into for caching. It can really increase performance, and it's not very hard to implement. All right, so there's a ton of options out there, but don't let it overwhelm you. Just try things out, see what works see what works the best for you. All right, so we're going to talk a little bit about ORMs, or object relational mapping. These are programs that we use as a layer of abstraction over the actual database. So it provides a way for us to interact with our database from our code or from our application without having to write raw SQL queries, which can be kind of a pain in the ass. So it simplifies data interaction, it increases productivity, it also keeps our application independent of the database. So if you wanted to build an app around, let's say, MySQL and use an ORM like Sequelize, you could then later on swap MySQL for Postgres if you wanted to and not have to change anything except maybe some configuration options. All right, so certain ORMs support certain databases. I'm going to go over some of the popular choices that you may run into. I also want to mention that certain frameworks have built-in ORMs as well. For example, Laravel uses an ORM called Eloquent, which is fantastic. So some other ones are Prisma, which is extremely popular right now. It's a type-safe client that supports just about all the popular databases like Postgres, MySQL, MongoDB, even SQLite, and some others. So it has an extremely easy to use API. It can handle relationships. It has advanced pagination and many other features. So if you need just a general ORM or database client, that's what I would suggest. Now, if you happen to be using Node.js with MongoDB, Mongoose is an incredible tool for connecting and interacting with your MongoDB database. Like I said, NoSQL databases don't need to be structured at the database level, but Mongoose allows you to do all that from your application layer using models and schemas. And there's also support for middleware, which makes it very customizable. And then Sequelize is an ORM for Node.js, but for SQL databases. So it supports all the common ones. It also has database migration capabilities. You can create models just like you can with Mongoose. There's a concept of hooks, which you can use to manage or hook into lifecycle events. That's really popular for Node.js. Now, to step out of the JavaScript world, SQL Alchemy is an ORM for Python that works with common SQL databases, and it has a rich API for making complex queries. Now, there's obviously a lot more for many other languages. For instance, Doctrine is a popular PHP ORM. You have Hibernate for Java, and many more. So I can't go over all of them, unfortunately. This video is getting way too long, but I want you to know that there's just tons of these out there, so just experiment, see what works. All right, so when we create a backend API, there's a couple approaches that you can take. Two of the most common are REST APIs and GraphQL. Now, REST stands for Representational State Transfer, and it's a software architecture style for building scalable and flexible web services. Now, you should really be familiar with REST if you're already a front-end developer, because you should be able to consume REST APIs from the client. And this knowledge will help you when it comes to creating them as well. So REST is the traditional client-server model, and it's much more common than GraphQL, and it uses specific HTTP methods and endpoints, or URLs, which are formatted in a certain way. Now with REST, you can fetch data from a route, so let's say, whatever, mywebsite.com/API/posts. So you would fetch all the blog posts from that specific endpoint or that URL, and then you would get all the data back from that endpoint. And you could use any language, any server-side language in any database. You could create a REST API with Node.js and MongoDB, or with Java and MySQL, or whatever language you want. Now, GraphQL is a bit different. So GraphQL is a query language and runtime for APIs, and it allows clients to request the exact data they need in a single request. And it uses a flexible and expressive query language. So this can lead to performance improvements, especially for mobile and web applications. With REST, let's say you have an app where a user can create, read, update, and delete blog posts. So you would have 4 separate URLs or 4 separate endpoints to hit on the back end to commit any of those actions. And if you wanted to get a blog post, you would have to fetch every field in that post: the title, the body, the date, the user or author, all the fields you'd get back. With GraphQL, you have one single endpoint, which is just /GraphQL, and instead of making a standard HTTP request, you make a query, which looks a lot like JSON. And you can specify, well, I want just the title and the body from the blog post with this ID. So you can specify exactly what you want, where with REST, it's more all or nothing. All right, so that does increase performance, and there's a lot of pros to that, but GraphQL is also harder to set up. It's another layer that you have to worry about. You can use GraphQL with a REST API. They're not mutually exclusive. But with that said, I think that learning RESTful APIs, it's mandatory for full stack and back-end developers. GraphQL is a nice technology to know. It can help you out, maybe get you jobs that you couldn't get otherwise, but it's not something that I think is mandatory right now. All right, so a big part of web development in general is authentication and authorization. So for beginners that don't understand the difference, authentication is the process of identifying an individual. So a user logs in, they validate their identity. That's authentication. Authorization pertains to the permission that that individual has. So just because someone's authenticated and logged in doesn't mean that they can do whatever they want and go into like admin areas and start to edit content and all that. So for that, you usually have some kind of role system with authorization. Now, as far as how to implement this stuff, there's a lot of different ways to do it. So the traditional approach is to use sessions and cookies. This is where the server maintains a session for each user that's authenticated and stores a session ID in a cookie on the client side. And that session ID is used to retrieve the user information from the server on subsequent requests. And it will enforce any authorization rules. So if you're using a full server-side solution, like let's say Laravel with Blade templating, this is really easy because the framework and maybe an extra package or two gives you the tools that you can use to implement this. Now, when we start looking at single-page applications and having a lot of the app rendered on the client, it does get a little bit more difficult. And one solution for this is JSON web tokens, or token-based authentication. So basically, we create an endpoint on the back end for the user to authenticate with a password, and if they validate or authenticate, then they get a token. And this is typically a JSON web token and usually has the user's ID encoded with it. And then that gets sent back to the client, and then anytime the client wants to access a protected route, they can send that JSON web token with the request, and then it's validated on the server. Okay, so that's one way to do it. Now, you also have things like you have OAuth, which is a simpler solution. It's an open standard for authentication used by many services like Google, Twitter, Facebook. It allows users to grant third-party applications access to their data without sharing their username, password, and any sensitive data. So I'm sure you've been on plenty of websites where you can log in with Google or Facebook, Twitter, GitHub. So that's usually OAuth. Now, to make it even easier, there are third-party services such as Auth0 that use the OAuth standard to give you an identity management solution that provides authentication and provides user management and security features. So with Auth0, for example, you can integrate authentication with Google, Facebook, LinkedIn. So it just makes it a little bit easier. And that's probably what I would recommend starting with. So chances are you'll have to learn a few different ways to implement this stuff. These, I would say, are the most common. Some other things that have to do with security and authentication that you'll be learning about are password hashing. Obviously, you can't store plain text passwords in a database, so they have to be hashed. And you'll probably want to look into two-factor authentication. I think that in the future, two-factor authentication is going to be a must on most websites. It kind of is now, but I think it's going to be even more common. And then protecting routes in your APIs using middleware, things like that. All right, so when it comes to deploying a full stack project or an API, it's a bit different than deploying a basic front-end website, because you can pretty much host a front-end site anywhere. It's put on a server, it's delivered to the client, but server-side applications need a server to execute your code, and that code could be in one or more different programming languages. So there's two main categories when it comes to these services. You have a PaaS, which is a platform as a service, and this is where pretty much everything is done for you. You don't have to provision a server, install Nginx and firewalls and all that. All you really have to do is push your code to something like GitHub and then select the repo from within the platform, much like you do with Netlify or Vercel. So then you have unmanaged cloud hosting, which is where you essentially rent out a Linux box, and you can install whatever you want on it, any Linux distro, any programs you want, whatever. You set up Nginx and your web servers and all that. But of course, that's much more difficult. So I'll start with the platforms as a service. So render.com is what I would suggest using. It's super easy. You can host Node.js, Python, Ruby, Rust, Golang, just about any modern programming language, and it's simple to deploy. It's very similar to how Netlify works, at least from the user-facing website. They also have a very generous free tier if you want to try it out. Now, Heroku is a platform as a service that I've used for a long time, and I've used them a lot in courses and videos because they did have a very nice free tier that you could use for testing and stuff like that. However, they stopped that free tier in 2022. Now, don't get me wrong, I still use Heroku personally, but I need a free tier for courses because not everyone's going to pay for a hosting account when they're just taking a course and they're learning and they're testing things out. So now I kind of ship everybody to render.com for courses and tutorials. But Heroku is a good service, and it's a little bit more difficult than Render, but it's much easier than using just a cloud host. Now, if you do want to use cloud hosting, there's a few companies that offer this. Linode is one that I've worked with for years. They're great. DigitalOcean, there's a company called Vultr, and they're all pretty similar. They all have basically a a portal that you can log in and you pay as you go. You can install whatever you want, including the operating system. You can choose your Linux distro, and you have to set everything up from scratch. So you'll be installing your web servers, and you'll be installing Node.js or Python or whatever it is that your backend is using. So this does take more knowledge, obviously, but it also gives you a lot more freedom. So I did want to mention AWS here because it does have some amazing services that host some of the largest applications and platforms in the world. However, for me, it's a bit overkill. So anything that I build is fine with other solutions that I mentioned. I'm not really an AWS guy. I log in and I don't really know what the hell I'm doing other than creating some S3 buckets for some images or something like that. So it's really not for me. I know a lot of people really like it. Azure is a similar platform by Microsoft, which I have no experience with, so I can't say much about other than these are really, really powerful services with powerful infrastructures that host really, really large applications. All right, so in addition to hosting, there are some other technologies around deployment, DevOps, storage, and so on that you may want to look to as a developer and definitely as a DevOps engineer if you plan on going that way. I'd say that most of these are optional. Aside from the terminal, I think that if you're a full stack or backend developer, you should be very comfortable with Unix commands. You should be able to use a bash shell or a Z shell. You should be able to navigate the system, create and open files, etc., and be familiar with SSH so you can interact with your servers and so on. Now, if you use something like Render or Heroku, you don't have to worry about setting up web servers, but you should have at least an introductory level of knowledge on either Apache or Nginx. Those are the two very popular web servers. Apache has been widely used since the 90s, and it's really popular in PHP. Nginx is a more modern web server designed for high performance and scalability, and it's used a lot for modern application and microservice architectures. So having a basic understanding of how these work and also some of the major config files is definitely a plus. Now, another technology you may get into, especially if you're getting into DevOps, is containerization. So this is where you package your project and its environment in any dependencies it has, including server software, databases, languages, and anything else, into what are called containers. And then your container can run on any machine, and it will run the same exact way because it's running in the contained environment, which is going to be the same on every machine. So this is very beneficial if you're on a team and you have projects that have to run on multiple machines. And Docker is definitely the containerization platform that you're going to most likely run into if this is something that you're going to do. There are some others like Vagrant, but Docker has really shined in this area. And then you have Kubernetes, which you can use to manage your containers. Now, if you're a beginner or a freelancer or someone that mostly works by yourself, I don't think you need to get into Docker or anything like that, but it is great for collaboration where your development environment has to be a certain way on multiple machines. All right, so you're going to have assets like images, documents, videos, etc., where you need to store them somewhere. And you're not going to use GitHub to store hundreds or thousands of images. So there's all kinds of services for stuff like that. I really like Cloudinary. It stores your media, but it also optimizes it. It creates multiple versions of it. So you may have a large version for desktops, large image, and smaller versions for tablets and smartphones. And you get a nice API with all the image URLs. So you can integrate that into different platforms really easily. In fact, in my Next.js course, we integrate Cloudinary into the Strappy Headless CMS. So Amazon S3 is a storage service that's part of Amazon Web Services, probably the only part of it that I use. And you can use that to integrate into your projects pretty easily as well. And there's all kinds of libraries for Node.js or whatever you're using. Now, the last two I'm not very familiar with. CI/CD stands for Continuous Integration and Continuous Deployment, and this is more towards the DevOps side of things. So it involves continuously merging and testing code changes from multiple developers into a shared code repository. So it's more to ensure that code changes are compatible and they can be integrated into the code base without causing issues. And there's tools to help with this like Jenkins, Traversy, Circle CI, but I don't have any personal experience with them. The next one, Infrastructure as Code, or IAC, I don't really know much about either. It's more DevOps, but it involves writing and maintaining infrastructure as code using tools like Terraform, CloudFormation, and Pulumi. All right, so we've gone over a ton, and I'm sure that some of you are overwhelmed. Just know that you only have to learn a very small portion of what we've talked about. And the reason that I mention so much in these guides is to show you all of the options. A lot of people on YouTube, they'll have you think that the only thing out there is like JavaScript and being a MERN stack developer, but there's a lot more out there, and you'll find out when you start looking for jobs. So we talked about a lot, but as far as what you absolutely need to know, you need to know a server-side programming language or technology. Obviously, Node.js is not a language, but it's a server-side technology. So you're fine with that. You're fine with just about any other language, especially the languages that we talked about. You definitely want to look around in your area and see what's really popular in terms of the jobs that are offered. All right, so a language, a framework, so you want to know a server-side framework in that language. The fact is you're going to be using a framework. Why reinvent the wheel? You're not going to just do everything from scratch. So frameworks are, they make things a lot easier, and they're more secure than if you were to just use vanilla code, and there's a lot of advantages to it. So databases and ORMs, so you should have some experience with either a relational or a MySQL database, even something like Firebase or Supabase. You should know how to implement that database within your code, including connecting and querying it. Okay, you should probably know at least the basics of SQL, structured query language, if you're using a relational database. You're probably going to learn some kind of ORM to use within your code, something like Sequelize or Mongoose or SQL Alchemy, something like that, so you're not writing raw SQL queries. So you should be friendly with the terminal as a full stack developer. You should be able to navigate your system on in a bash shell or a Z shell and run Unix-based commands. So REST APIs, you should fully understand HTTP requests, the whole request response cycle, how to create REST APIs. You should also be familiar with authentication, including sessions and cookies, even JSON web tokens or something like OAuth. And then you don't have to know all the DevOps stuff we talked about. I certainly don't. You don't need to know Docker or anything like that. It is helpful. But you should at least know how to deploy your projects to production and create an environment for continuous deployment. So those are pretty much the bottom lines for being either a back-end or full stack developer. Obviously, with full stack, you need the front-end stuff we've already talked about. Okay, so even though this is a web dev guide, there's web technologies that can be used for other things, such as mobile development. If you strictly want to be into mobile development, then you might learn something like Swift for iOS or Kotlin for Android apps. But we do have web technologies that allow you to create cross-platform apps that you can run on both iOS and Android. So React Native is obviously a popular choice if you're already familiar with React. React is a UI library, and when we use it to build web apps, we use it along with a library called React DOM. So if you're building a mobile app with React, then you're just not going to include the React DOM library. Instead, you'll include React Native. So you still have the structure of components and state, and you get some added things as well, obviously. But when you build a React Native application, it's going to run on both iOS and Android, and that's a huge advantage, because if you're using, let's say, Swift to create a mobile app, it's only going to be on iOS. If you want that same application to run on Android, you're basically building a whole separate app using Java or Kotlin. So with these technologies, you have one single code base. You might have some configuration to change around for each platform, but that's about it. You still have one single code base, which is huge. All right, so Flutter is another cross-platform mobile framework by Google, And Flutter doesn't actually use JavaScript. It uses a language called Dart, which is very similar to JavaScript. So a lot of JavaScript developers do actually go into learning Flutter. And Flutter is it's a bit faster than React Native because it doesn't have that extra step of having the React Native bridge. Flutter code actually compiles to ARM or Intel machine code, as well as JavaScript for fast performance on any device. Now, Ionic is a framework that's been around for a while, and you could build hybrid apps and progressive web apps with it. And I'll talk about PWAs in a minute. So Ionic isn't going to be as performant as React Native or Flutter, but you're also not bound to any specific framework. You can basically do whatever you want. You can use React, Vue, Angular, etc. All right, and Ionic apps are also cross-platform. Now, we also have Xamarin, which is a C# framework for building mobile apps. So you can utilize the .NET framework. It's very high performance, cross-platform. As you can see, there's quite a bit that you can do with C# from Blazor to Xamarin, from web to desktop. C# is something that I've dabbled with, but I want to get more serious with it in the next year or so. So that's one of my plans. I really like C#. I've used it for some small Windows utilities, but never really used it for web development. So there's also a framework called NativeScript. I don't have it on here, but it really hasn't went anywhere as far as I can tell. I know that it has had some hardships, including changes in leadership and obviously competition from other cross-platform frameworks, but it is still actively maintained. So progressive web apps will remain relevant in 2023. In fact, I think we'll hear more about them. They provide the best of both worlds, both mobile and web experiences. And PWAs don't use any specific framework, but rather leverage modern web technologies such as responsive design, service workers, web app manifests, HTTPS, to provide an app-like experience on the web. And PWAs are responsive, installable, they're fast, and they can work obviously across multiple devices and platforms. So anyone that knows HTML, CSS, and JavaScript can build progressive web apps. There's just a few extra steps that you need to add on from it being a regular web app. Now, there are web technologies that you can use to create high-performance desktop applications. Electron is an open-source JavaScript framework for building cross-platform desktop applications. They run on Windows, Mac OS, and Linux, and it's a JavaScript framework. And it basically just takes care of the hard parts and lets you focus on your application's functionality. So you can use any front-end framework or library that you want. It comes with a native UI that runs on all three platforms. And before you write it off as being some janky JavaScript solution, let's look at some of the software that's been built on Electron. So we have VS Code, Atom, which is another great editor, Slack and Discord, which are, I would say, the two most popular chat clients, Skype, which it used to be one of the most popular, OBS, which is used widely by streamers and content creators, and even Postman, which is an HTTP client that we use for building APIs and stuff. And that's just some of the applications that are built with Electron. So it's extremely powerful. I would say if you do want to use any web technology to create desktop applications, then that's what you want to use. I did put some other stuff on here, though. There's the framework called NWJS, previously known as Node WebKit, and it's similar to Electron. It's just not as popular or as full-featured. It does let you create native Windows, Mac OS, and Linux applications. I do have a tutorial on NWJS as well as Electron. I actually have a full Udemy course on Electron, but it is quite out of date. That's why I didn't move it to my platform. All right, so with Python, you have a bunch of different frameworks you can use to create GUI apps. Tkinter is one of them that's pretty easy to use. I believe I have a tutorial on Tkinter. And then, of course, you can build native apps with languages like C# and Java, but I think that goes beyond web development, so that's why I'm not really going to talk about that much. All right, so next we have WebAssembly or WASM, which I've mentioned a few times already. So this is a binary instruction format for browsers to run code more efficiently than JavaScript. And you can use very low-level languages such as C, C++, and Rust. So technically we're able to build stuff that's much more powerful than what JavaScript can give us. So it has been quite of a slow rollout, in my opinion. I remember when it was released, people were saying that JavaScript is going to die soon, which is very stupid. You'd think people would learn by now that that doesn't really happen. Aside from HTML5 killing Flash, which did seem to happen overnight, at least to me, that doesn't really happen much. So WebAssembly made some strides in 2022. Major browser vendors like Google, Mozilla, and Microsoft continued to invest in improving WebAssembly performance and integration. It's also moved beyond the browser now with projects in server-side and mobile development. So I think we'll see more of WebAssembly as the time goes on. Now, as far as trends go, I think that we're on the same road that we were last year, but one thing I see exploding in the near future is AI. And I talked about GitHub Copilot and ChatGPT. So these are both tools from OpenAI, which is where at least the open source and open to the public cutting edge AI stuff is coming from. In addition to those, we have Dolly, which is a new AI system that can create realistic art and images from just a simple description in natural language. In fact, my last tutorial on my channel was building an app using Dolly. So AI-powered databases, we have tools like MidsDB, which can merge the capabilities of a database with machine learning frameworks. And I think writing queries with SQL will be a thing of the past in the coming years. I think that we'll be able to talk to our database and just say, create a table, whatever, and not have to be very specific, just be able to do it with natural language and voice control. AI-powered content. So if you've used ChatGPT, then you know how well AI can put content together. Jasper is an AI tool for marketing copy. And this is something that freelancers could use with their services, along with AI tools for SEO. Mintlify is an AI documentation writer. It can be installed as a VS Code extension. So there's just so many new tools that are coming out now that take advantage of AI. Chatbots are huge, obviously. There's even chatbots for like customer support, for mental health, acting as counselors. So I think that creating chatbots is going to be pretty common for developers. Then, of course, we have code generators, so GitHub Copilot. There's also Tab9, Kite. There's a bunch of others as well. Now, I know a lot of people are scared that there's not going to be any jobs left in the future, and I'm not going to fully disagree with that. That's a whole nother video, but right now and in the coming years, use it to your advantage. I think that just sitting around complaining about it's not going to do you any good. Right now, you can use these tools to really help you in coding and in your everyday life. I mean, I use ChatGPT not only for coding and solving issues there, but also just everyday issues. If I need to fix I actually used it to help me diagnose an issue with my water boiler. So, I mean, you can use it for anything. So this stuff is far from perfect, but this is the first year where I can really see the potential of AI. Now, I've been talking about using AI for development, but you can also create AI and machine learning tools if that's something you're interested in. I would suggest that you get into Python and things like TensorFlow, Keras, H2O. There's so many different Python tools out there that you can use for machine learning. But I would say that area of programming is beyond web development. Now, let's talk a little bit about Web3. So I think that last year, Web3 was overhyped just to the max. I don't think I've ever seen anything so overhyped. You know, there's definitely potential in Web3, and I think it's a big part of our future, but people were acting like Web 2.0 was going to disappear overnight. And it was just pure comedy. Just like WebAssembly was going to kill JavaScript, Dino was going to kill Node.js. you'd think people would learn by now that things roll out much slower in reality than they do in people's heads on social media. Now, with that said, I think that, like I said, Web3 is going to be a big part of our future, and I think learning blockchain development at this point can be really valuable. You get a jump on it now. So blockchain is a distributed database that's used to record transactions in a securely and transparent way. So it can be used to create decentralized applications, or DApps or dApps, however you want to pronounce it. And these are applications that are more secure and transparent than regular traditional web applications. So smart contracts are self-executing contracts with the terms of an agreement between a buyer and seller, and they're directly written to lines of code. So they can be used to automate complex transactions and reduce the need for intermediaries. And I think getting into Solidity, which is a programming language used to create smart contracts, can be very beneficial. Again, especially where this stuff is so new, it's good to get a jump on it. So cryptocurrencies such as Bitcoin and Ethereum can be used in Web3 applications to facilitate transactions. Web3 identity solutions such as Uport provide users with more control over their personal data, and it enables them to securely interact with decentralized apps. So yeah, I think that getting into Web3 is a good idea, but it's not something that you're going to go and get a job with right now, at least as far as I know. All right, so congratulations. If you sat through all that, I commend you, because this was a long video. It was way longer than I anticipated, and I apologize for that. But I wanted to just get all that stuff out there. There's a lot to learn, and I didn't want to just say, well, this, here's the front-end frameworks, React, Vue, Angular. Here's back-end frameworks. I wanted to talk a little bit about each thing so that you have an idea of what this stuff actually is. All right, so as far as choosing what you're going to use, don't let it overwhelm you. There's a ton of stuff here, but like I said, you only need to learn a fraction of it. Just try stuff out, decide what you want to do, and that can always change. You might say, well, I want to be a front-end developer, but then a year down the road, you want to be a full stack or even a back-end developer. So things change, but just decide on what you want to do right now at this moment and find the best technologies for that, and try a couple things and see what really clicks with you. There's always been technologies that I've used where it just kind of comes quick and it's easy to pick up for me, and then there's some where I'm just like, I don't know what the hell I'm doing. So you just got to find what works out for you. All right, so that's it, guys. Thank you so much for watching. I appreciate it, and I will see you next time.